Top of the morning to you, Peter.
Top of the morning to you.
We came here to talk about Tansu, and I don't want to try to define it, so I'll just leave you to define it. What's a one sentence summary of what Tansu is?
One sentence. This is going to be a long one sentence. Tansu is a modern Kafka compatible broker with multiple storage engines. You can start with SQLite and you can end with Postgres or S3. It has schema validation broken in the broker. Lots of really nice things, and it's aimed at developers. It's aimed at being useful and easy for developers to use to start using. How's that for several
That's a
steps?
pretty good. That's a pretty good one. You must have practiced it. Okay, so it's stateless. It's single binary, and you mentioned something about pluggable backends. So you said I think you started with SQLite. What are the backends that Tansu supports?
So it supports a variety. So an important concept within Tansu is this idea of a storage engine. So it's separate to the broker. So the broker is given a URL that it's going to use for storage. So that URL might be memory. You might want to create a very ephemeral environment that is just using memory as a storage engine. So that's an option. There's also SQLite. SQLite's very popular. The nice thing about SQLite is it's a single database file. So you might want a Kafka environment where you're using SQLite as storage, and perhaps it's a test environment and you want to reproduce that environment. It's as simple as just copying a single DB file to your new test environment. There's also Postgres. Lots of people run Postgres. Lots of Kafka systems end up in a database. There's all these sort of things happening, and then ultimately ends up in the database. And
Yeah,
part
I
of
want
the
to talk about
idea,
that.
what's that?
I want to talk about that later too.
Okay. Part of the kind of original concept or the original itch I was trying to scratch with Tansu was everything ends up in the database usually. So why not have something that just allows you to put things into the database straight away? So that's kind of where the Postgres connector came together. So you can use Postgres and then S3 because everybody does S3 and S3 is the thing. So the difference with Tansu, I think, is because it's stateless. And with S3, I use optimistic locking. Uh, so there's no additional coordinator. And I think most of the other platforms is an additional coordinator. There isn't with Tansu. And that has pros and cons because I'm obviously doing conditional writes. That conditional write, if you have multiple brokers, they're obviously going to be competing on hot areas of the S3.
Okay.
Um, so that's basically the different. There's also a null storage engine, but that's not interesting unless you're doing tuning. Um,
Yeah, that's a lot of stuff. It's a very interesting project, Tansu, and that's why I'm so excited to talk to you today about it. We have a lot to unpack. But let's start with you. Like, what's your history? What introduced you to Kafka? Why even work on Kafka? What's the story?
I've been using Kafka for a long time. I really like Kafka. I think Kafka is an amazing project, an amazing product, and it's kind of the universal thing that everybody uses. Um, and I've been using it for probably at least 10 years. But I've not been using it in Java, and I think this is one of the areas where Kafka is kind of. It would be great if Kafka was better in other languages. So for a long time, I was writing systems in a language called Erlang. There's no Kafka client for Erlang. There's nothing for Erlang, but there's certainly no decent Kafka client. So I ended up writing a Kafka client, and that got me very heavily into how the protocol with Kafka works, understanding some of the benefits and the limitations of the design of Kafka. So, for example, having leaders for partitions, having leaders for transactions, or leaders for consumer groups, and the ping pong between the client and the broker when the broker isn't when the broker's in flux. So, if disk space is an issue or network is an issue, what are the impacts on the client? So, I was thinking a lot about that in the back of my head when I was thinking about Tansu. Um,
You must have been, but wait, you implemented a whole client in Erlang,
yes, yes.
producer and consumer.
Everything, yes, especially the consumer side. So that's live in a production system that's dealing with lots and lots of transactions per second. Um, that platform has its own consumer. Because it's all Erlang, we were able to adapt the consumer protocol. So we did things that I think Kafka does now, but we did it a little bit ahead of ordinary Kafka. So we did things like sticky topics, so that if you have a rebalance, then you're guaranteed to get the topics that you had previously, because we adapted the protocol slightly, so that the leader of the consumer group actually knew what the allocations were before the rebalance. And so when it did the reallocation, it could basically say, you used to have this topic, this partition, you can keep having that topic and partition. And so we did that in the Erlang side of things, because we knew we were always going to be having Erlang clients.
Which year was this?
Quite a while ago, but at least 5 years ago, probably closer to 7 or 8, if not 10.
So 2018-ish.
Yes.
Can you tell me a little bit about that experience building a Kafka client itself? Because as far as I know, the protocol wasn't and still isn't. It definitely wasn't well documented back then. We didn't have the JSON files, for example, that I like more now. But yeah, and there were no other Kafka implementations, at least from what I remember, or no popular ones. Today, it feels like everybody in their grammar has a Kafka broker implementation, protocol implementation. But yeah, tell me a little bit about that process of implementing clients. Like, did it take a long time? Was it just you?
So I had a small team. We were looking at various areas where we could. I've always been very interested in the stream processing side of things, of having event-based systems, and the platforms that I was working at the time, they weren't necessarily very good fits for database systems. So there were very good fits for, if you imagine a stock exchange where the price is changing continuously, using Kafka to stream that was essentially what we were doing. And you're right. Kafka we kind of ignored for quite a long time because of Zookeeper. Zookeeper was there, and I think offsets were being committed to Zookeeper in that stage of Kafka. So if you wanted to commit an offset, you had to use the Zookeeper API. And the Zookeeper API was basically, I think, serialized Java objects, which don't work well with Erlang at all. And you're right. So at a certain stage, there was a set of eBNF protocol definitions that were on KafkaApache.org, and I literally cut and paste those protocol definitions and wrote a little parser that took that eBNF and then produced it into something that Erlang could understand, and then something that a serializer and deserializer could understand. And you're right. It would be great if the JSON files were there at that stage, but I don't think they were. Right now, if I was writing the Erlang client now, I would be starting with those JSON files, because they're generally a pretty awesome thing, and it's what Tansu uses now to generate all the protocol.
I don't think I know what eBNF is. Is this
extended Backers now form? It's the one where you have the something and then an equal sign, and then it expands into these other things. So a produce request is a list of topics, and it was basically a bunch of square brackets. If you look in the API definitions, even on the Kafka, if you search for Kafka protocol, then it's kind of in those eBNFs are still there together with the JSON. But the JSON is now the definitive how does the protocol work, because that's how the Java stuff also works.
Yeah, I just opened actually a Wikipedia page about it. I don't think I've seen those. That's really cool. That must have been a lot of work. What?
To be honest, it wasn't too bad. I mean, Erlang's pretty flexible, and so it's completely untyped, so you can throw lots of things at it. And we basically took that and then produced protocol from it.
I mean, no, not just the protocol parsing, but also just having to learn the protocol if you didn't know it before, having to write a full-fledged two clients actually that handle all the intricacies.
I think that's another interesting thing, another great thing, and I'm going to keep on saying how great Kafka is, because I think Kafka is great. The great thing about Kafka is it's kind of this inverted design that there is a lot of complexity on the client side. So like most of the consumer protocol runs on the client. The Kafka server is electing a leader. That's it, pretty much.
Yep.
And everything else is then down to the client. But lots of the other things like produce and fetch is really quite simple. I think that was before idempotent producers, so we weren't having to worry about epochs and those kind of things. Um, so
Yeah.
generally, it's pretty simple. You can write something that does produce and fetch reasonably simply, and then adding consumer groups. We initially weren't doing that because of zookeeper side of things and committing offsets. But as soon as we could commit offsets into Kafka, then that kind of opened the door to us to be able to do lots more.
Yeah, a quick side on that idea of most of the logic being in the clients. I remember, back in the day when I was writing about Kafka, one of the things that articles would claim was great about Kafka is this fat client and thin server approach, where the logic was of the clients. And there's arguments for both sides. And back in the day, I was just seeing the arguments for the fat client side. But nowadays, I'm definitely seeing us moving away from that. And I don't know if it's just Confluent, developed a cloud service and figured out how bad it is when you can't control the clients, or we're just becoming more, cloud native with thin clients and all the logic is just abstracted away in the cloud or in the backend. But we're definitely moving to a world where most of the logic is on the broker side. So for example, the new consumer group protocol pushes most of the assignment logic into the broker. And I'm sure we have other KIPs for other things as well that are sort of pushing more and more logic into a broker. Do you, as a quick side, what do you think about that in general?
So Tansu doesn't at the moment support that new protocol, and that's just something that I haven't got to yet. There's no reason that it couldn't, but I basically assume that at the moment that the vast majority of clients are still the classic. I think they're called classic consumers. So very much classic side of things at the moment. I think the idea of moving more things to the broker is kind of fine, but it's kind of one of the things I liked about Kafka was the simplicity of the broker. And I worked a lot with MQ, the big IBM MQ. And they're very different platforms. They're very different things. Very, very different things. I kind of like the broker is really quite simple. And I really like that as an idea. And that's kind of part of the idea about Tansu as well, is just try and keep things really, really simple. I'm not trying to cover all the bases. I'm trying to cover the 80% of what people want to be able to do, and I want to be able to make that as simple for people to do. That's part of the reason why things like SQLite, you can just start with SQLite, and if you want to, you find your project's really, really successful, or you go beyond the bounds of what SQLite can do, you can then use Mirror Maker or an existing Kafka tool to move your data to a different storage, or even to Kafka if you wanted to move it. It's that kind of flexible if you want to be able to do it.
But it's funny you say that you like the simplicity of the broker, because my understanding for most people is that what they hate is actually the complexity of Kafka itself. And my take on the matter, before you say what you think, is I don't think the broker is actually complex. And I don't think Kafka is complex per se. I don't think it's doing anything that's too, cutting edge or out there or hard to comprehend. But I think my understanding is that complexity in Kafka comes from the vast plethora of permutations and options that you can configure. So we have more than 300 configs. We have all these different types of clients and all these different types of, for example, delivery guarantees, at most once, at least once, exactly once, etc. And my understanding is, or my thinking is that this complexity comes from the fact that there's just so many notions, so many ideas, so many different configurations. And I think somebody who's new to the space comes and sees all of this and they're like, wow, I have no idea where to start. I don't understand the trade-offs. I don't know what I should do. It's just too hard. And then, of course, they deploy with the defaults and then something breaks or something doesn't work the way they expect. I think that's also a big thing. I think people come with some preconceived notions of how a messaging system should work.
Yeah, absolutely.
And then Kafka doesn't exactly match that. I think Kafka has reasonable defaults, by the way, but anyway, anybody can have any notions, and it doesn't match that. And then I guess it just takes them some time to understand. If that is true, I think that is true. Then Tansu may be the answer to something like that. I think, I definitely believe we need something like what do you call the pathway where the planes take off? Just a single road, a big road, very easy to do. You know what you want it for, and if it needs to be complex, then the system may allow you to configure more complex stuff. But as you said, 80% of the cases they just want the the simplest solution. What do you think about that?
I massively agree with you. I think, I'm going to say it again. I really like Kafka. I think Kafka has saved my life on many, many occasions. But I do think some of the complexity is not well understood. Lots of people don't understand the 300 plus options because it's 300 plus options. The number of times I've spoken to people and they've said, we just use the default. A number of people with 3 replicas and 8 partitions or whatever the default is, because that's what comes up. And then the number of people who don't understand that after they've been in production for 2 weeks, why all their offsets have just disappeared because the the retention time was just not set to what they expect. So so Tansu doesn't have retention on doesn't have an option of setting the retention on offsets. If you commit an offset, it's committed, it's done. And because I've been caught out by that lots of different times.
Yeah.
And so there's some options that I think, so there's kind of the highway that is Tansu, and I think it will be, Tansu is Kafka API compatible, but isn't Kafka. It's obviously not Kafka, it's something different, it's written in a different language, and so I think it will be opinionated as to how it should work, and hopefully provide sensible defaults that make sense to the majority. And
I love that quote. It's Kafka compatible, but it's not Kafka. I love that.
Yeah,
the offset retention thing actually got me googling it. It's 2 days. So yeah, the default offset retention setting is 7 days. So for those who don't know, consumer store offsets in Kafka, and if your consumer group is inactive for a configurable amount of time, 7 days by default, the last consumed offset would get deleted. So I assume this setting exists because we're also assuming that the retention of the topic would be 7 days. So if your data or if your offset record is deleted, then it doesn't make a lot of sense to store the offset. But how did you get caught by this setting? Or
obviously, I've never been caught by such a mistake ever.
Yeah.
But I hear.
Word on the block is okay.
I hear that. There's a couple of things that just in the time of using Kafka that are just sort of little footguns of it's all perfect, but you're not monitoring disk space, and there's a hot partition, and for whatever reason, the broker that has that hot partition starts to run out of disk space, and everything's working fine apart from that one partition, and nobody notices for weeks, days, weeks, or months, depending on how good the monitoring is. And they're those kind of things that I think are hard. And the other motivation that I have is the number of times that I've gone to an infrastructure team and said, we want to deploy Kafka, and it's an on-premise installation, and talking to the storage people, and I say, well, Kafka is going to replicate the data 3 times because we want it to be resilient. And they kind of just do a facepalm of, well, the storage you're using is already replicated 5 times because it's a network attached storage, and we've spent millions of dollars on this storage to be durable and replicated. And you're now saying that you want to replicate on top of the replication. And that's part of the motivation behind Tansu, of kind of separating the storage. Of the storage is responsibility for the durability, whereas so there's no replication in Tansu of those things because of those kind of conversations with operations teams where they built this platform and you're now using something that is assuming that you're linked in. And I think that's another important thing about Tansu. It's not trying to pretend to be linked in. It's not trying to say you can have 400,000 topics and petabytes of data. This is for the average person on the street who wants something that can act as something where they can produce messages to and something they can fetch messages from.
That's great. That's a great point, that Kafka was really created for an on-premise world in a specific on-premise configuration where every broker just has one disk, and it has to explicitly replicate between each other. I think you're absolutely right with the network attached storage, or even in the cloud today. EBS is replicated within the AZ, or was it the region? I think within the AZ. S3 is replicated. Depending on your configuration, you are storing data redundantly many times. And another thing that I've thought about is how needed is that actually? We advertise these defaults of, replication factor equals 3 and spread across 3 AZs, so you have this SLA. I don't know the SLA numbers off the top of my head, but I'm pretty certain that if you store replicated data within 3 disks within the same AZ, that the SLA for availability and durability is good enough for the majority of users. Now, I think nobody thinks about that in particular. It's again this artifact from the LinkedIn times where you have this very big company, it has these very strict requirements, it needs to be available under all costs, and people just adopt this technology with these configurations, but truth of the matter is they probably don't care if they're down for, let's say, an hour every year. Or
yes, and also the number of cases where Kafka isn't the primary data store of that data. That data is coming from somewhere else, and we can reproduce it. Is another thing that I always think. Well, if the data is coming from somewhere else and you can reproduce that data, then that's another use case that why you're then replicating this data 3-5 times just to make it durable.
And this has costs. This has organizational costs because you need a platform team to manage this and
yes.
And track everything. And as you said, if the monitoring is set up, if not, I've seen so many clusters with alpha monitoring. Customers have to pay, let's say, Confluent to help them with their on-prem installation because they don't even have monitoring.
Yeah.
How can you manage a Kafka if you're not even monitoring what's happening? So that forces you to use either a managed solution or some vendor who can, save you when things go wrong.
So the platform that I was talking about, where it was Kafka, and we joked amongst the team that we hadn't built a platform to process transactions. We'd actually built a metrics processing system because we had so many metrics. We had a live dashboard of every broker and telling us how much disk space it had, how under-replicated partitions were, all these things, and the timings on consumers and producers, just to make sure that we could confidently say to the board that this platform is operating well. So I think we were probably an outlier there. Most teams, it's kind of you deploy it and you forget it until it starts to go wrong, and then part of the problem then is, well, what is normal? What does normal look like for this platform? And that's where you're then into trying to reverse engineer dashboards and everything to try and work out, well, what does this system normally look like? Is
especially
memory usage normal or not?
Yeah, it's a great point, especially if you don't have the muscle. That's one of the good and bad things about Kafka is that it's actually pretty stable as software. So it runs and runs and runs for months on end. Yes. And then maybe it breaks because you misconfigured something or you didn't maintain it properly. Yeah. And then what do you do? Because you don't even know how to maintain because you haven't maintained it, you haven't hit problems.
Yeah.
It's a very interesting topic. But let me ask you then. Go ahead.
I was talking to somebody recently and they were talking about compaction. And this platform, compaction had been fine, and then it suddenly stopped working. And there was something in the data, you might not notice that compaction has stopped, but you will certainly start noticing because the consumers are now processing more keys than they were expecting to process, and so even those things. So compaction in Tansu, certainly on the SQL side of things, is a SQL query. Which is really one of the things that I like about the SQL side of Tansu and both SQLite and Postgres is you can get a normal SQL engineer to go and look at the database and say, is this working well? And then you can use normal SQL tools to understand it. Whereas with Kafka, you're looking at segments, you're looking at disk storage, number of file descriptors that you've got in use. Is the cleaner working properly, and why might the cleaner not be working properly? And understanding all those things are just a different skill set. And I think the interesting thing about running it on SQL in particular is there's a lot of that experience usually within companies.
That's a good point. I think we should define Tansu at this point for the listener, so we're all on the same page, because I already have an idea of what Tansu is. So let me try to explain it, and you can explain where I'm wrong or where I'm missing something
Tell me what I've
fundamental.
been doing for the past year.
Yeah. So Peter, you've been working on a stateless Kafka proxy. I would even call it a proxy, but it's basically a software program that speaks the Kafka protocol. So producers and consumers connect to the program. It's written in Rust, by the way. And that program supports multiple backends. So if I focus on, let's say, one backend, let's focus on the Postgres SQL backend. So I have a Postgres database that exists somewhere, and it has its configurations, it's replicated, etc. That doesn't really matter as far as Tansu is concerned. And I spin up a Tansu broker, and my producer connects to Tansu, and Tansu saves everything, including consumer offsets, the producer data, the cluster metadata, meaning what brokers exist or what your ACLs are, or any other sort of what topics you have, how many partitions they have, all these configurations. Everything is stored in Postgres in some way that I don't know and don't really care about necessarily. And that's what makes the Tansu broker stateless, because I have Tansu broker 1, I can spin up a second one, that second broker would read everything off of Postgres. And because there's no replication between the brokers, meaning they just store it, as you said, the storage engine is Postgres, so they just store the data in Postgres, and they don't care if they don't replicate between each other. So Tansu broker 1 has no idea, doesn't even necessarily need to know that Tansu broker 2 exists, because they don't need to connect to each other, because they don't need to pass any data between each other.
That's correct. So Tansu brokers have no idea about any. As far as Tansu broker is concerned, there's no other broker. It's just itself. So the way I like to think of it is every Tansu broker is Spartacus. I am Spartacus. And so it doesn't matter if that one disappears, because nothing is lost. You know, it's everything is written, staying with SQL, everything is written as a transaction into the database, and everything else is a query into the database. So if you want to know the high watermark for a topic, that's a query to the database. It's not stored in the broker at all.
Okay, so conceptually then, it is more similar to the warp stream, buff stream model, potential auto-MQ, potentially diskless Kafka or confident freight, in that it's leaderless in that sense. If we have many brokers and they don't know about each other, they have to, by definition, be able to serve every partition.
Correct.
In the cluster. So I think that's where things may become a little complex or different from regular Kafka. So can you explain to me maybe in a simpler way, if I have Tansu broker 1 and Tansu broker 2, and I have two different producers and they produce for the same partition some data, and both of these brokers at the same time, what decides which data gets in first? What decides what the latest offset is? How is that sort of locking and contention point solved?
So speaking purely about the SQL side of things,
yeah,
so you're doing a produce. If you're an idempotent producer, then one of the things that it's doing straight away is checking the sequences table to make sure the sequence that you're providing for that producer is the correct sequence, so you're in sequence. That's one of the first things it's doing. Then it is, and this is within a transaction, it is then increasing the offset for that partition, topic partition, by the number of entries in that batch, number of records in that batch. And then it's writing each of the records within that Kafka batch as separate records in SQL into a table, confusingly also called record.
It's a separate row, you mean?
Yes, they're separate rows. And the reason why it's doing that is because if it's doing schema validation, it has to go to each row anyway. Each row has to decompress it. So it's Kafka API, but it's not Kafka.
But it's not Kafka, yeah. So that's the first major divergence from Kafka I noticed. So Kafka, for the listeners, Kafka is heavily optimized to write as much records in a single batch as possible, and to not validate. Kafka is completely agnostic to the data, so it doesn't validate every record. It gets a batch of records which a producer produces. Let's say that's 16 kilobytes worth of records, or could even be a megabyte, depends on how you configure it.
Or 100 megabytes.
Or 100, yeah. And that's what allows it to have this high write throughput, because it's just persisting the batches into disk in the lock, and that's easy. So what you've taken an interesting divergence here. You've taken the record batch and you've split it into every record, and you're just putting row
Correct.
in the Postgres table. And that helps you with schema validation. That makes sense to me. So do you have schema validation inside the broker?
Absolutely. So out of the box, and this is broker schema validation, the broker will schema validate against Avro, JSON schema, and protobuf. And the broker's, so basically what I was describing, the broker splits up the batch, and for each record within that batch, it has to do a schema validation. So that's one of the key differences between Kafka and Tansu, is the broker side schema validation. And then
what does schema validation mean exactly in this context?
So you have so there's no schema registry in Kafka. A schema registry in Kafka is a URL, and the URL is either a file URL or an S3 URL. And what Tansu does, if you're writing to a topic called test, then what Tansu says for that to be schema validated, there must be in the S3 bucket where you're storing your schemas, there must be something called test.proto, test.absc, or test.json, depending on which schema you're using.
Mm-hmm.
And what Tansu will do is when it gets a produce request from the client, it will split the batch up. It will decompress that batch to start off with if that's what needs to happen. Then for each record within the batch, it will then validate that against the schema that has been stored in S3. If that batch isn't valid to the schema, it rejects the whole batch.
Okay. So in terms, but you have to reject the batch because that's the level what the protocol works on. So when you say it validates the schema, that basically means there's a specific word for this. But let's say I have a schema with 3 fields: number equals 1 or number, text, and let's say Boolean. And you're saying that your sort of schema validation will be okay if Boolean is missing and it's a required field, then we fail. Absolutely. Or if you give and also depending on the compatibility, if you give me a 4th field, I may or may not fail that as well.
Yes, so there's only a single version of the schema ever, and that's principally because my assumption is most people are using protobuffer now. Mm-hmm. Protobuffer has a built-in way of adding to the schema. Basically, you have records, fields 1 to 3 in protobuf. If you want to add another field, then it's field 4, field 5, field 6, and you can upload that new schema and it will still work with old versions of the data, and you can use new versions. So that's kind of the way that Tansu would deal with changes of schema.
Okay, so that's different than Kafka schema registry, because as far as I understand, feel free to correct me if I'm wrong, is that Kafka schema registry contains they call it multiple versions of the same schema per offset. So the idea is that, let's say if you produce up to offset 1000 and you change the schema after that, you have schema v2. After 1000 is the schema v2, and at any one point in time, there could be a case where both schemas exist in the log. If you have offsets from 0 to 2000, half of it is the old schema, the other half is the new schema.
Yeah.
So schema registry, because it's all on the client, this is not on the broker side at all, sort of tells your client to know which schema to use based on the offset. You're saying that Tansu, because first of all, this is now in the broker, so the broker has to validate all of this. It's just one schema, one version, and you're saying that works because modern schemas like protobuf, they already handle that.
Yes, of changing the schema. So you can have I think most people are using protobuf for these kind of things now, and protobuf has a way of versioning schemas. You can basically start with 3 fields and end up with half a dozen fields, and as long as you keep to the field sequencing, you can still have clients using the old version of the schema and clients using the newer version of the schema, and there's no reason to have the schema registry. And the schema registry, to me, doesn't make sense anyway. That's a Tansu opinion there. The idea that you're going to go and make a HTTP request to a service that might be unavailable to go and fetch a schema, which is already compiled into your program, just doesn't make sense to me.
No, and then client-side validation, and it's complete. Schemas are completely broken in Kafka. I can talk about that a little bit. But on the schema side, so how does Avro and JSON compare then with that schema evolution? I know protobuf, as you said, if you keep the serial order of the fields the same, which is basically what 99.9% of people do, because that's the way you evolve a protobuf schema. It's probably really hard to evolve it otherwise. I assume the tools won't let you.
Yes.
But how does Avro and JSON compare?
It doesn't. Being really honest with you, it doesn't work so well there. I mean, JSON schema has issues anyway that, and this is more related to when Tansu is then trying to write this data as delta or as Iceberg tables, is JSON schema isn't precise enough. So, for example, when JSON schema says something is a number, that means it can be an integer or it can be a float. And that is difficult when you then try and write that to a delta or an Iceberg table, because delta and Iceberg want to know, is it an integer or is it a float?
Mm-hmm.
The Tansu tries to make a guess based on the data that it sees in that batch as to whether it's actually an integer or a float. My recommendation is if you want to change your schema, use protobuf and use the mechanisms within protobuf to do that. And I don't really have a good answer for Avro.
Okay, that's fair. I think the whole schema story in Kafka is a set of these path-dependent decisions that were made for one reason or another, maybe with good intentions at the time. And I think just the way everything has evolved with supporting new schemas. I don't think when Kafka was created, I don't think protobuf was popular. Frankly, I'm not even sure when protobuf was created, but I think everyone was focusing on Avro for streaming data. That was sort of what Confluent was supporting as a first-class citizen. That's what was recommended.
And this may be my own bias a little bit, but I'm trying to think of non-Java clients specifically.
Yeah.
Because I think that is an area where Kafka, if you look at the Kafka market, where could Kafka be really interesting? Well, to me, the answer is where Kafka isn't now. So,
yeah. You're absolutely correct.
Outside of Java, there are lots of companies with a full Java stack on the client and the server side who are using Kafka and very happy with Avro. There are lots of people who are using Go and Rust and Python and other languages like that who would very happy to use protobuf because that's what they're already using to communicate. And that's kind of part of my concept around Tansu is being more open to those kind of systems and being more open to the way that they work. And anybody who's worked on a protobuf-based system, it's very strictly regimented how those schemas are changed because you've got knock-on impact throughout the system if you change it in an incompatible way. So the vast majority of companies using protobuf have mechanisms in place, either humans or
tooling,
to basically check that schema is compliant. I thought having me writing a schema thing registry just wouldn't make sense in those contexts because you're already compiling against that schema, and you're not going to fetch the schema to then compile it to then use it.
I like that. I like that also. Should I call it thriftiness or that focus on what do I need to work on and what is maybe not necessary?
Yeah.
Screw Java, screw Java, honestly. I like the language. I wrote in it for 5-6 years. I actually enjoy it. The ecosystem is fine as well. I'm not someone to complain too much, but Kafka is really overly focused on Java for whatever historical reason. And I kind of understand that, the money to be made is in Java because most of the very big commercial deployments of Kafka are probably Java shops for one way or another. I mean, enterprise equals Java, right? You hear enterprise and you just think of Java. But this is changing. Year by year, this is changing. And there's also this under focus on non-enterprise use cases for Kafka, which I think I would argue, and you can argue, that maybe that's not the right tool for the job. Like, why would you use Kafka in a non-enterprise setting if you have some small deployment or etc. But nevertheless, it doesn't hurt to optimize for that, and you will never use Kafka for such settings if you never make it usable for such settings. So I very much welcome that development.
I massively resonate with that point as well. I think to me, would you use Kafka where you've got to deploy, you have to deploy a minimum of 3 brokers. There are environments where you don't need to do that. If I've got a small project where I know the volume of messages is going to be relatively small, why not just start with a single broker? And I run a lot of my stuff on Raspberry Pis because I want to be able to run it on small environments
Nice.
where I can just run stuff and not have to worry about having the biggest machine available with necessarily a huge amount of CPU.
I think
Everybody cares about energy usage and how much they're actually using now, and I think that's another interesting space. Sorry.
yeah, that's validated in the market in a sense because we have Red Panda's claim to fame was just not being JVM, not being bloated, being a single binary. And this made it developer friendly, and this made them able to deploy, to create tools that let you deploy Red Panda with just one click. I heard of stories of people using Kafka in production, but using Red Panda in the CI CD because it was just so easy to spin up, and the other thing was a mess. And since it's Kafka compatible, you can run your tests against the same Kafka thing, which I think was hilarious. And then we have other systems like, let's say, NATS. I hear about NATS all the time. I'm not sure how popular it is, but it seems more popular in the Go space or in the cloud native sort of CNFC space. To be fair, they had some issues with the open source model. I think the company behind it tried to close source it a few months ago, up to a year ago.
This is the CNCF project that was CNCF and then has sort of. I think it's still probably CNCF.
Yes, Synedia
Yeah.
is the company behind it. They had a dispute over it. I'm looking at it now 8 months ago. They tried to withdraw the project. So
Yeah, that's it.
That's very bad. But systems like this, people show NATs all the time in my comment section. They say that it's simpler, it's one binary, etc. It's not directly compatible to Kafka for what it's worth, or it has 1,000 features as well. So it has like some Kafka compatible feature, and the rest is like a lossy queue, which doesn't persist to disk. But regardless, I'm just showing you that there is some sort of at least developer interest in these very simple other language sort of native implementations. And what does it mean to be native to Go, for example? Nothing much really, right? Like maybe support a gRPC API, or be native to Kubernetes, allow you to deploy in Docker and Kubernetes easily. But beyond that, like, what's the big difference?
I'm less au fait with Go. Rust is really previously being an Erlang guy. I kind of looked at Go for a bit, but there's no pattern matching in Go, and pattern matching is so important to me. And Rust just has pattern matching. Which is, I just use the idea that you use string comp or something like that to compare strings, which I think you do in Go. Whereas in Rust, I can just do match and magic occurs.
I love that in Scala too.
To me, that was the blocker for Go. I think the
That's a change engineering answer, man.
it's garbage collected and all sorts of things that I just think make it harder to understand, particularly in production. I think there are sharp edges that I don't want to have. And then the other reason for Rust was it's really easy to create C bindings, and those C bindings, it's very popular for people to use Python with Rust. And I think Python is the sort of data scientist space, and I think that's another interesting area where Tansu and Python could be interesting together, and enabling better Kafka compatibility through using the Tansu Kafka client, which is very early stage, but does exist. Tansu uses it for its admin API and all sorts of things. So part of what I want to do with Tansu is write a client, including the proper consumer groups and everything, that could then be used by anything that can talk to Rust. Wait,
this is getting interesting.
And I think that's another interesting space where you can kind of open out Kafka into more areas. And I know there's the C sort of library that we didn't use the C library in Erlang because we weren't sure that it would be stable.
Liberty Kafka.
Yes. And Ultimately, I think what Tansu will do is have a client that can be used by multiple different languages, particularly Python, and it will be a first-class language because it's just using the Rust bindings of a library.
Wait, let's step back a little bit. This is interesting. I didn't know this. So, to step back, Tansu is an open source project. It's on GitHub at tansu.io Tansu. It's all written in Rust.
Yes.
The license, it's an Apache license, right? Okay, these are all important things to say and to know. It is in Rust, which I think is awesome. I love Rust personally as well. But we don't have to get into a language war, whatever it's written in. So you're saying you're planning to create a client? And that exists already?
There's already a client. It's just not very well full featured. So, for example, if you look at Tansu, Tansu is a single binary, but there are subcommands within Tansu. So the most obvious subcommand is broker, which runs the broker. But there's also a proxy, which I use for debugging issues when somebody says Tansu isn't compliant with Kafka. I run Tansu as a proxy in front of Kafka. I can record all the protocol, understand what's going on, and if Tansu isn't doing the right thing, it isn't returning -1 where it should be returning -1, I can spot that and I can make changes. So I use that internally to make things work. But there's also an admin API because I was annoyed with having to tell people to use the Kafka tools to create topics and to list topics and delete topics because Tansu should be freestanding. So there's a topic subcommand where you can create a topic, you can list topics, you can delete topics, all in the same 50 megabyte binary. And that's the beginning of a client because Tansu, to create a topic, needs to be able to make a client request to the broker to use the create topic API to create that topic or to list the topics. What have you got there?
Yeah, so I should be sharing my screen of the Tansu repository. I thought I would show. Yeah, so this is the topic command, right? And the proxy here, this is the command.
Need to make you a tiny bit bigger.
I can also make it bigger.
Yes. So, but if you go docs.tansu.io as well as some, if you go to the URL docs.tansu.io, then there's a bunch of stuff about the subcommands as well. That basically
beautiful docs.
About. There's some prettier documentation on docs.tansu.io. So this is basically talking about the broker.
Oh, sorry, I didn't share the tab.
Yes,
my bad.
Yeah. So if you scroll down to, on the left-hand side, if you scroll down to CLI, and then you can see, so there's topic, and this basically goes through what you can do in terms of, so this uses a really cool library in Rust called CLAP, the command line argument parser, and basically you can go and list, create, delete topics, all within Tansu. And it's using Tansu itself, eating its own dog food to create the client. So basically, it's doing that using its own client. So there's enough in there to do all the API. The only thing that isn't there that's major at the moment is the group consumer. But the group consumer will happen because if you look, there's some other commands as well as tansu-cat, which allows you to basically take files of data and cat them into a broker, and also cat them from the broker into your CLI. And the awesome. Cat is also compatible with schemas as well, so you can take protobuf, because this was another thing that annoyed me, is I wanted to be able to take protobuf data, cat it into a broker without having to use proto-C to compile it and everything else. So you can use a JSON format. There's a JSON format of protobuf data, and you can basically take that JSON format, Tansu will convert it into protobuf for you automatically using the schema, send it to the broker will validate it, and you're able to basically cat data, protobuf-based data straight into your broker.
What is the JSON version of protobuf? I've never.
There's obviously the binary version of protobuf, which is the way objects are serialized across the wire. But there's also a standard way of writing protobuf data in JSON.
Is it proto-JSON?
I could probably look it up for you. But there's this, yes. So that Tansu uses that, and basically takes the JSON. So it's nice and easy to write JSON. The idea is it's a CLI tool. You can write your JSON object. Tansu will then take that JSON object, write it into binary protobuf, and then send it to the broker, who will then validate it against the same schema. And the client tool is using the same schema as the broker.
Dude, I love that. So one thing I love about Tansu in general is that like it's so engineering focused. It's like you're one developer, you found these issues in Kafka that just kind of annoy you, like having to compile the protobuf or having to use the
an itch.
Yeah, exactly. No, and having to use the admin client and these Java tools, and you're just rewriting everything. And it's sort of Tansu is like the epitome of you can just do things.
Yes.
You know, you can just recreate things. So I love that.
I love that knife there of that.
Yeah, I love that you've recreated some of the CLI because, truth be told, it should be recreated. It is the Kafka CLI has a lot of issues. It's just annoying to use. It works, but it's annoying to use. This looks much better so far. So that made you sort of create a client because obviously you need this. And now you're planning of implementing actually the full produce and consume at some point?
Yes. The producer's there. Well, all the API is there because it's generated by Tansu anyway. It generates something like 60,000 lines of code from the JSON descriptors of all 80 plus descriptors that are in Kafka. So the protocol's all there. It's then writing the layer on top of it that does the consumer group, that does item post producer. So they're the pieces that are missing. But the underlying protocol is all there.
Makes sense. So what are your plans then with these clients? You mentioned something about Python bindings, but are you actually working on this right now, or is it just an idea that you may work in the months to come?
It's an idea at the moment, but it's a natural thing within Rust to be able to produce bindings that can be used by other languages. So you can produce a C binding from Rust, and that C binding can be used by Python. There's also mechanisms within Erlang to basically take Rust bindings and use them directly within Erlang. So I think there's a lot more flexibility using that, and also because of the safety guarantees that you get from Rust, I think people will be a lot happier using a Rust-based API than a C-based API because you know it should be safe.
Yeah. The Lipardi Kafka has its problems. It's also a bit legacy, and I'm not sure it's easy to develop against and maintain. But are you then planning on potentially? Oh, you wouldn't change the protocol, but it seems like you're sort of slowly maybe building this path where you have your own client with its own new APIs or own sort of particular behavior.
Potentially, I can kind of see the motivation of. Is there a way of mashing together some other concepts that are not from Kafka and kind of putting them into something that isn't Kafka anyway? Tansu isn't Kafka. It's different because storage is separate. It's stateless. It doesn't replicate data. Could you put another API on top of Tansu that is more like something else, more like MQ or another kind of queuing system?
But also not to do it at the service. Tansu is Kafka compatible, so it's a drop-in Kafka replacement, right?
Yes.
And that's always sort of going to be the plan?
Absolutely.
Right, okay, so that's important.
I think there's a huge market for Tansu in existing platforms that are, want to use S3, or maybe they aren't as big as the Kafka and medium replication, will just use SQLite. Lots and lots of companies run on SQLite. And to me, that's another interesting space that it could be.
I want to underscore the importance of being API compatible because there's a meme for this, but there are hundreds of competitors of Kafka messaging systems that have came and gone, and there are some new ones today like Northgard. There was this one other in Rust, which was an Apache project. I don't even remember the name. But the reason I don't cover these at all and I don't really look into them necessarily is because the network effect of the Kafka API is just so strong that you cannot kill it without being at least 10 times better.
Yeah.
And the people who are in the systems that are sort of 10x better in quotation marks or somewhat better, they still choose to just use the Kafka API because that's where the distribution is. And distribution is everything
Yeah.
in this sort of software. It's like trying to create a new database without supporting SQL.
Postgres, yeah.
Like,
Yeah.
why would you do it? Why? There's no reason. So that's why I'm not interested in these other systems. I am very interested in what else you can do that's not Kafka, but unless you support the Kafka API, I never see that taking off. So that sort of disinterests me as well. But I think that path, that planned path of always being Kafka compatible, becoming the Kafka, and then offering new APIs on top of, if you want to use it, if you want to develop a new client or etc. And like that's very valuable, I believe. That's awesome. So I think you should focus on that, and I'm happy you do.
I'm very, very focused on being Kafka API compatible, and it's not to be underestimated because it's not a simple thing. Tansu, I've been working on Tansu for at least, publicly for a year. Originally, when I released it, which is probably pretty much a year ago, it was AGPL licensed rather than Apache licensed because I wanted to get it out there to tell myself that once it's out there, it's done. And, I couldn't roll back from it. And originally it was AGPL licensed because I was kind of shields up. I didn't want contributors. I didn't want people to disturb me until I was happy with where it is. And then I started getting people asking me about, well, I'd like to start using the client side of this. And that's when I switched it to Apache because people were now starting to be interested in it and be starting to use it. And I wanted to be as open as possible in terms of how Tansu could be used. And in terms of my commitment to it, I'm self-funded, I'm self-motivated, and I want to build a really interesting Kafka-compatible but not Kafka system that can be used across a number of different platforms. And to me, that's very compelling. And I think what I'm seeing is lots of adoption from people who aren't normal Kafka people. So I'm not interested in killing Kafka because I think Kafka has its right place and it's kind of in that space already. But I'm interested around the periphery of that as well, of if you're using very small systems, you're monitoring, I don't know, greenhouses or things like that. That's not somewhere where you might put Kafka at the moment because you don't have 3 machines and all sort of associated stuff to do with Kafka. But you might have a small device that could run a broker. And a Tansu broker, will run in, I'm running 600,000 messages per second through Tansu, and it's using 17 megabytes of RAM, which is...
Megabytes.
Megabytes. Which I'm still not sure about because it just feels wrong. But that's kind of the difference. And, there's 1 kilobyte messages and those kind of things. So it is Kafka. It's Kafka API compatible, but it's not Kafka. It's a different thing. And I spent probably, talking a little bit about Rust. Rust is a difficult language to learn. It's not easy, and it's well known for that. And Tansu, probably the first 6-9 months of Tansu was taking those JSON descriptors that we were talking about earlier from Kafka and trying to work out how to write a proc macro in Rust that could do 80 plus, I think there's 88 Kafka APIs that are described by these JSON descriptors. Take those JSON descriptors, and those descriptors are written by humans, which also mean they have some mistakes in them, like they're not quite consistent in terms of how they use, and it's only like 1 or 2 cases, and there's the odd version of Kafka where things are a little bit different. It's particularly in the new APIs. But basically take all those descriptors and produce code from that Rust can then use to serialize and deserialize the Kafka API.
Yep.
But that's done now, and that means that, and most people don't do that because if they're writing a client, they only care about the one version of fetch. Whereas I, as a broker, have to worry about all 18 versions of fetch.
Yeah, that makes a lot of sense.
Most people just go, well, I'm using version 18 of fetch because that's what I'm going to use. Whereas as a broker, I have to deal with all of them. So Tansu deals with the original fixed length protocol. It also deals with the compact protocol, the flexible protocol rather, as it's called in Kafka, which is using basically for variants for a lot of the API. And then it also deals with tag buffers, which are these things that allow you to... Normally the Kafka API is very religiously versioned with every change, whereas tag buffers allow you to add things into the protocol without changing the version, and Tansu also deals with those.
But we covered a lot here. I just want to tell you, it makes me so happy to hear what you're building and that you're self-funded and you're self-motivated and the vision behind it. I really love it. Honestly, I'm most bullish about Tansu of all the Kafka projects right now, and I just really hope it succeeds. It's something I want to succeed, especially in today's age where Confluent is getting bought by IBM. Some of the other companies haven't got acquired yet, or they may be getting acquired, and nobody is really growing revenue. It feels like we may be at a point where the Kafka market might slump, or the very, very best case, maybe just stay sideways in a way, stop improving. So seeing something like this makes me really happy. You touched on a few topics that I actually have bullet points that I wanted to ask you about, but before that as well, the Rust thing, Rust is very difficult to learn. It has, what do they say, it has this big steep learning curve, but then once you learn it, it's better. I used Rust back in 2017 when I was still learning. It was a very hard language back then as well. And I just tried to create like a block server API, so like a React frontend and a blog API. I did that. I tried to port some stuff, some of my data structures in Rust. I succeeded with some, and I banged my head against the wall trying to port a red-black tree with recursive references to each node in Rust, and I failed completely. I just couldn't get it to compile. So I can sort of understand your pain in learning the language and porting a whole project like Kafka and all the protocol into it. Then you said you released it 1 year ago, but when did you start working on Tansu? And again, why did you? What was the thing that made you actually like get in it, the project?
So the project itself, before it even went public with the AGPL version, which was kind of the first version that I was kind of happy with, but anybody really to look at. But it was kind of, I wanted to make it open source so I'd done that. Just mostly to kind of incentivize myself of, well, you've now done this, you now need to keep on doing it. And so Tansu is probably 2 years old, but probably the ideas around Tansu go back a lot further than that, of when I was working on the platform that I was talking about. One of the things that we needed to do was integrate with a data team, and we had everything was in Kafka. Everything, even the HTTP requests that came into this platform were converted into Kafka requests that were then dealt with by the platform and then responded to. So we had a very rich set of data that we could use. And the data team were very interested in that, but they couldn't read Kafka because Iceberg didn't exist and Delta didn't exist. So one of the things that I wrote was a Amazon, I think it's called Amazon time stream, and was able to basically take Kafka data and stick it straight into Amazon time stream, which allowed the data team to basically be able to understand raw Kafka data. And that was one of the things that platform did, and that was probably the initial idea behind Tansu of, wouldn't it be great if we could just write this into a database? Because ultimately there was a data team that wanted to understand that data. So that's probably 7 or 8 years old, that idea. So it's taken me a long time to get to that point.
That's super interesting.
But it was kind of this openness of data is the other thing that I'm interested in, which is why I support Delta and Iceberg, but also why I write the individual rows into the database, because I think they're going to be more useful to a database engineer if they're individual rows than me saying, oh yeah, it's just a segment, you can't understand it because it's a segment.
Yeah, so then if I can ask why are you creating yet another Kafka, I would answer this and then I'll let you answer it. It's simpler to deploy and manage, and stateless, which allows you to spin it up and down and scale it up and down, and It's in Rust and very low resource usage, which again, as you said, allows you to run it on a Raspberry Pi or something much smaller if you're just using 17 megabytes of RAM. And then the fourth thing is because it's SQL compatible, that kind of changes the game as well into how you're able to analyze the messages, potentially do other sorts of things with the messages, and further opens the path many years down the line if you want to implement different features or different clients or etc. Is this sort of the take on why Tansu, why you should even care about another Kafka implementation amidst all these others?
Yes, I think that's a great description of what was in my head, and it's an interesting route as well. I haven't woken up one morning and thinking, I need to put it on Postgres. I had a conversation with a good friend of mine, and they said, wouldn't it be really great if I could do this? And it was like, oh, actually, that's pretty easy to do with what I've already got. So it's been influenced by a number of different people. The initial version of Tansu was way more like Kafka. So it had Raft in it. It had segments. It was writing to the disk. And then I was having a conversation with somebody, and it was like, why are you doing it that way? Why don't you think more about how it could be used with? They weren't talking specific about S3, but more cloud services. And that was kind of the motivation of, well, let's make it stateless. So I think you can probably go back to the beginning source history of Tansu, and you'll probably find there's a terrible implementation of Raft that I did. And there's an even more terrible implementation of segments, which never worked. Just it never got to that point. But that's kind of where the ideas are floated around. It's kind of solidified around this idea of being stateless. I really like the idea of having something that I can spin the broker up, handle an API request, and spin the broker down. Because you've never been able to do that in Kafka. There's all the other things that are going on, like compaction. Even spinning the broker up, it's got to go and check its disks, make sure the segments are all okay. There's quite a latency before you can even do those things. So, so that is kind of, that's why I said kind of at the beginning, I'm Kafka API compatible. I love Kafka. I think Kafka is really, really good. But I'm not Kafka. It's something different. You can use it in the same sort of ways. It's probably slightly more opinionated than a default Kafka installation. And that was kind of the motivation.
I love that. I love this statelessness. I think it's a topic that's not talked about enough. I think the only truly stateless type of system today, I think, is WarpStream. Maybe also, I think BuffStream also is. And they have this ability to really truly just create the broker, produce whatever you want, and then spin it back down. And that gives you a lot of benefits. Let me try to iterate to all of them. So first, it gives you very easy auto-scalability. It's very trivial to write a Kubernetes HPA autoscaler that scales up a new pod the moment it needs it and scales it down the moment it doesn't. Potentially also to 0 if you have no requests to send. Then on the placement side, on the cloud networking placement side, so in the cloud, your networking costs depend massively on what your network topology is. So there are different costs if your two pods that communicate to each other are in the same VPC, if they're in the same AZ but different VPCs, if they're in different regions, if they have private link connectivity between them, if they have VPC peering connectivity between them, if they have transit gateway connectivity between them. It's really massively complex, unfortunately. But being able to scale these pods, having stateless pods literally means that you have the ability to actually co-locate the broker with your program, with your pod, potentially on the same EC2, in the same VPC for sure. And it theoretically allows you to run embedded as well. Yeah. That's a lot of things to cover. I want to talk about the embedded later, remind me about that. But and that's what makes it so easy to use. That's what makes it so easy to use. Like it also decentralizes, I think, the ownership aspect. You no longer necessarily have a single platform team that owns, let's say, Kafka.
Absolutely. So that was another key motivator of I've been in organizations where there's a team that owns Kafka, and there's a centralized Kafka that, and I never found that work very well.
Yeah, tell me about that.
So because of I think there's a number of factors around this. One of them is the clients are not all written by the same company or the same organization. You might be using a JavaScript Kafka client that is very, very different to a Python Kafka client to the Java Kafka client. So they're very different. They're all using the same API, the same protocol underneath, but they're very different in the way the frequency that they might fetch or the way they touch the API. And the noisy neighbor problem in Kafka, I don't think really goes away. If you've got somebody who is doing massive fetches continuously, they're going to impact other people in a large platform. And part of the motivation around Tansu was being able to give each team their own Kafka system. And because it's simple to manage, they're not having to worry about a large platform team sort of taking ownership of those things. And that was kind of part of the motivation of being stateless, having separate storage, just to make it simpler for people to actually manage it is a key motivation. So it isn't necessarily a centralized platform team that's managing a large Kafka installation. It's instead lots of small Tansu instances that are tuned for that particular system. So one might be using S3 storage, the next might be using SQLite, because they're different. They have different non-functional requirements.
That's a very interesting point. That I never thought about that actually. Then does that introduce some friction when you want to connect the different systems together? And actually, in your opinion and experience, is there a need to connect these systems? Or otherwise, if I have team A and they have topic A, and I have team B and they have topic B, and let's say in this case, one uses SQLite and the other one uses S3, have you seen many cases where you actually need to join that data within the same sort of consumer client, or Kafka Streams client, or whatever Kafka compatible client?
In general, no. I mean, generally, a team will be working on the topics that they're producing. There might be some overlap, and that overlap can happen. You know, there might be a shared topic. There might be a shared topic of what products they can offer, or that kind of thing. There's nothing to stop you from using Mirror Maker to bring that topic into that cluster, into that Tansu instance, and similarly taking things out of Tansu. Mirror Maker to me is the great advantage of being Kafka API compatible is you can use existing tools, and you should.
You can just connect it. Yeah.
So,
well, tell me a little bit. Tell me about your experience with working in Kafka. So you said, or you hinted that you had this platform which actually parsed HTTP requests into a Kafka record, potentially the responses too. Can you explain a little bit more about how that whole thing worked, what the use case was, and what your experience was? Was that worth it to do? Because we're sort of touching into the central nervous system idea of Kafka. If you want these topics to be connected to each other, we're assuming that Kafka is the central nervous system of your company. And that's what could potentially mean that some client needs to read multiple topics from multiple different teams in real time. That's a key factor too, in real time, because if we're not talking real time, you can just dump it to S3 in Iceberg and read it after 20 minutes.
Absolutely, yeah. So I've worked on a variety of different platforms, but I guess the common thread is that it was very much real-time data. So if you think about stock market prices, the one thing you can't cache is a stock market price because it's changing. So the platform that we were writing was a system that was taking those prices and then taking orders for those things. So, and that system was obviously a web-based system. So the request would come in from the client saying, I want to buy so many of these at this price. That was a HTTP request. The body of that HTTP request was put onto a Kafka topic. Why on earth did we do that? Because we had all this infrastructure around the monitoring of Kafka. When I said a little while ago, we built a metric system. Basically, everything that went into Kafka, we had really, really good monitoring for. We could really understand, if there was latency, we could measure it really, really easily. and we could also put a tag on the request as it came into the platform, and we could see that go through. And everything was event-based, so the wallet would have a basically saying I would a reserve funds event. So if this notional purchase of a stock that came through the platform, the initial request would be a HTTP request where the body would be put onto a topic. The wallet service would be listening to that topic and looking for buy orders, and it would then reserve funds in the wallet, which if the buy didn't complete within a period of time, would then automatically be refunded back to the wallet. So the whole platform was entirely Kafka, and a lot of that was with Erlang services that were reading those topics. There were hundreds of topics in that platform. And one of our decisions was, because Erlang's known for being a very resilient, reliable platform, we only really wanted one dependency. We didn't want a HTTP dependency and Kafka. We really just wanted one dependency. And the real reason for that was we wanted things to fail if there was... We didn't want you to be able to make HTTP requests but not make Kafka requests, and vice versa. So we wanted everything to go to Kafka, so there was this essentially, if you like, a single point of failure that we were very much monitoring all the time to make sure that it was operating correctly.
Yeah, an atomic sort of failure almost. So you know that if one platform is down, everything is down. And
yes, yeah.
And you know very well what the impact is.
We didn't want a partial failure of sort of being able to... If we didn't want the services that we had talking using HTTP, we basically used Kafka to do that.
So allow me to pick your brain more about this. This is going into the OLTP use case of Kafka, and we can talk about the others later. But well, first, this was stock trading. Was latency of severe importance? Because if you want to go below milliseconds, Kafka can't really help you there. And also, talk to me a little bit about the complexity of this whole platform, because I'm sure it wasn't easy to create. You don't have any sort of framework for moving HTTP requests into Kafka or building event-driven systems like that. You're really sort of explaining the ideal case painted by Confluent and every other real-time streaming vendor. So tell me, also in retrospect, I don't know how many years this was ago, but in retrospect, do you think that was worth it? What benefits did you get? Where was it hard? Where did it fail? And would you do it over again?
The answer to the last bit, it was absolutely yes.
Yeah?
We'd definitely do it again. We'd probably do it in a very similar way. Like I said, I'm a very happy Kafka user. I think Kafka is really, really good, and we had a great experience with Kafka on that platform. Comes back to when I was talking about the client. So we wrote our own client, and the client basically had guardrails around the client. So the client,
what does that mean?
The client was very opinionated as to how things would be used. And that meant that when you were writing a service on this platform, it was very restrictive in terms of how you could write that service. So it was almost...
Can you give some examples? Is that like at most once, or if you remember?
It was interesting in terms of the way that the consumer groups worked. So I sort of said that we made changes to the way the consumer worked, because it's obviously the client is making those decisions. So for example, we partitioned the system based on the customer ID. So when that initial request came in, that HTTP request, first thing we'd do is we'd go and look at the customer ID, and we would then partition that request. So it would go onto one of 64 partitions, or however many it was, based on that customer ID. And that becomes really important when you are using a consumer. What you want to be offered are what we call slices. So if you're interested in the customer topic and the wallet topic, you needed to have the same partition always allocated. So you were given a slice. If you were offered partition 1 on the customer topic, you were offered partition 1 on the wallet topic, because that was the one that you were going to be writing your wallet request on when you receive that customer request. So we wrote this client that basically always ensured that you got the same, if you were asking for a number of different topics, you always got the same partition on that topic. And that meant that we could have very, very broadly scalable services. So if we had 64 topics, we could run 64 separate consumers, and they would all just get single partition that they were allocated, but they'd always get the first partition of all the topics that they were asking for, which meant that they could kind of do the whole sequence of events. If they were interested in several topics, they were always able to consume from the topics that were appropriate to the customer.
Right, so they would follow the full lineage of a certain business process or event.
Yeah, so it kind of, because we had that much control over the consumer, we were able to base it, and we called them slices, and it basically allowed us to make it really quite simple. You're fetching for a number of different topics. You're always guaranteed to be getting the data that is relevant to that hash of customers, and you're basically dealing with 1/64 of the customers.
I think that's a very important point. I think to make Kafka work in these complex OLTP systems, because this is complex, it's not a simple request response HTTP monolith or microservices. It's more novel. To make it work, I think you do need to implement some sort of custom client that that narrows down the possibilities of configurability and usage. I've seen users like OpenAI, Stripe, etc. implement their own proxies on top of Kafka, just so that they can simplify the API. And their API is not even Kafka compatible. For produce, they just have one API called produce batch, and it's in gRPC. For consume, they abstract the consumer groups away. So I think it's very important that the key for such organization-wide scalability is simplicity, and that's a necessary building block. So it seems like you did some sort of...
We did something broadly similar to what you described, and it meant that the actual code that members of the team were having to write was reasonably small. I mean, we were talking about services that were, the amount of code they were writing was low kilobytes in terms of the amount of code in Beam that it would have to load. And it was deliberately simple because it wasn't easy to get Erlang engineers, but it's pretty easy to train people to use a sort of simple version of the language and sort of narrow it down to the domain you're actually working in.
Right. So from that point of view, if you were to design the system again, do you think Tansu would be a fit? And are you trying to design Tansu in a way that would be a fit for this necessarily, or is that not the target use case right now?
Not as direct as that, but I'm very... one of my interests is the whole event-based idea. Sort of, and it kind of goes back to the idea of Erlang is that everything is a message. So having used Erlang for quite a long time, everything you do in Erlang is a message that you send to another process. Kafka became kind of an extension to Erlang of I'm sending a message to another process, but it happens to go through Kafka. And that was kind of the motivation. And Tansu, for sure, I think it's better if you can send lots of small messages to another system, not having 20 megabyte or 100 megabyte messages on Kafka. I know you can do that, but it's not, to me, the optimal way of doing those kind of things. And that's kind of where I'm at with Kafka. Just, if you were to store a 20 megabyte message in SQLite, that isn't going to work very well, and it's probably not going to work very well in S3 because ultimately it's
convention is to not do that in Kafka either. I think the max size was the megabyte by default. I'm not sure.
I think it's 100 megabytes you can before it gets The interesting thing to me is around Kafka is that the usage is so broad. You talk to people who, our batches were literally measured in milliseconds between each request, because if the price changed for the thing that we were trying to sell, you couldn't sell it anymore because it was now at the price. So we had to have very, very low latency. Whereas lots of other people, spoke to people where, their batch is end of day. and it is measured in megabytes. And that, to me, is one of the interesting things about Kafka is the broadness of the usage that it has.
Yeah, that's the superset idea of real-time streaming. You can support both batch and real-time with real-time, but with batch you can only support batch. So I want to ask you then, how are you thinking about latency then from the point of view of Tansu? If I have to guess, with S3 the latency is high, so it's pretty slow, especially if you're using that as a coordination layer. And with Postgres or SQLite, it must be super fast.
So I'm currently working through some of the. I've resisted is the wrong word. I've delayed doing tuning for as long as possible because my original focus was trying to get as much of the API done, and there's a great quote I think from Erlang of you make it beautiful and then worry about the performance. And I've been trying to get it to the point where I'm happy at looking at things. And part of publishing things to open source is you are exposing everything, and it's kind of interesting trying to explain to people why do certain things work in certain kinds of ways. So I've been avoiding doing the performance side of things, but probably for the last month I've been looking very much at how performance works in Tansu. And there is some great things in the Rust sort of space around how to do performance measurements. John Gunset has done this 1 billion row challenge, which is a 10-hour long video on YouTube, which is kind of interesting to watch. But it's kind of all the sort of process that you can go through. And so I've been tuning Tansu, trying to get that performance to a decent space. And the broker is able to respond in microseconds to requests that use what I call a null transport. So it's basically a broker taking a produce request and then responding back as if that produce request has happened. And that allows me to do tuning of the whole broker in isolation of the transport, of the actual storage itself, which is what I've been concentrating on at the moment. So,
you call it what? Sorry,
what was the question?
No, it cut out. You said you call it what?
What the null transport allows me to do is
the null transport.
Transport. So it's /dev null. If you're used to Unix, then it's the /dev null transport, and it basically allows you to acts as a sink essentially to a produce request, and isn't having to write it to any storage. And the round trip time there is in the microseconds, low milliseconds, microseconds, and that's doing hundreds of thousands of requests per second. And it's using 16 megabytes of RAM to do that. Measuring the resident set size of the program is using 16 megabytes. I think that's the interesting space.
That's crazy.
I think that's the interesting space when you think about the Internet of Things and monitoring your greenhouse. You can then start using Kafka for those kind of things that previously were not. It wouldn't be the use space that you'd be using Kafka for.
Yeah, so today for this IoT device, we use something called an MQTT broker, right?
Which the platform I was talking to, one of the original APIs it had was MQTT, and we pivoted and we ended up using a web-based API. But MQTT could be an interesting space for Tansu to implement. Basically, act as an MQTT broker with the storage layer underneath as an option.
Well, you certainly have the resource characteristics to compete there, it seems. How many records a second you said for 16 megabytes?
So I've got a. Should I share my screen and I can show you?
Yeah.
I can show you this very exciting screen.
So it seems like latency-wise, you will be limited by the storage engine. Mostly, if you're only taking even microseconds.
That's what I've been trying to tune so far. Is trying to get. So this is a kind of a part one of tuning Tansu, and this is essentially tuning Tansu without the storage engine attached to it. Because what I want to be able to do is tune the serialization and deserialization of all the API packets that are coming through Tansu, and removing all the hot paths. And the idea of the null storage engine is I can just tune that, and then I can look at storage as a separate thing. So if you're interested, there's some really great background material on actually how to go about tuning Rust and how you go about doing that. I mentioned this John Jensen Billion Row Challenge, which is 10 hours of YouTube, which is actually really good fun. Really good fun if you're into this kind of stuff.
Well, what is a 10-hour video? It's how he's implementing it?
I think you may have heard of the 1 billion row challenge, where you write in various different languages. Well, he starts from minute one of that video. He writes some code to do the 1 billion row challenge, and it takes, I don't know, 2 minutes for it to run. And at the end of the video, it takes 20 seconds to run, or whatever he got it down to. And it's kind of interesting because he goes through that whole process of tuning. And tuning is, to me, it's a series of dead ends that you kind of think, oh, I'll change this and it will improve the performance. And it doesn't end up doing that. And it's kind of going through that process. And kind of in my sort of takeaway from that is that I took a number of wrong turns, and you need to be able to measure consistently. And one of the key problems with tuning is getting a decent, consistent test.
That's a great point. So the storage backend kind of limits your tuning in that way because it's noise.
Which is an interesting one, because I didn't want to always be thinking, well, maybe storage was slow for that request. What I wanted was something where I could just say, I know this is going to consistently take this long or should take this long to run. Why isn't it running?
That's a great point. I don't think Kafka supports writing. No, can it actually? Do you know? If you set the Kafka directory to dev node, does that work?
I think it would be interesting if you did do that. It would be an interesting one to try, because it's also storing the topic metadata. So the null storage engine in Tansu, it has a hash map of the topics that it's created, so it can reply to the metadata. It also responds to fetches. It doesn't return any data in the fetches at the moment, and what I intend to do with the null storage engine is have some canned data that would always return with a fetch, so you can sort of measure those things.
That's great. I love this. I love this. So tell me more. How did the tuning go? When did you do this tuning? This was a recent work?
This is very recently. So many people have been asking me what's the performance like, and I've never had a good answer, and I'm still not convinced I have a brilliant answer, but I'm getting close to it. So this is kind of background into why, which we can kind of drop off, but it's kind of around the processing, and it links some of the great stuff about being open source. I've got some great documentation now around how the framing works, how the responses work, and it all uses all the nice stuff within Rust. So all the documentation is hosted on docs.rs. All the crates for Tansu are all hosted on crates.io, so you can go and look at everything that I'm talking about. And what I did was I wrote a custom bench for this benchmark. So I have a series of, and this is going to make you sound very strange, I have a number of Kafka packets that I've collected over the years.
What do you mean you collect the Kafka packets?
So I have produced version zeros. I have, and I've got, the more recent producers, and I've collected those together, and I've used those for to basically test protocol compatibility. But they're also great because you can use them to. What I basically do is I take some protocol that I know I've got from a Kafka broker at some point, and I can encode that and I can decode that. And if I get the same thing I started with, then the encode and the decode are good, because it's all work. It should be essentially an identity function.
Wait, quick side note, is this something you collected like many years ago before Tansu?
Bits before Tansu, but also the great thing about Docker is I can spin up old versions of Kafka, and I can basically spin up a 3.7 Kafka and send a metadata request to it, and then see what it's like in 4.1. And I capture all of those. And the other great thing that I really like is the testing side of things of Tansu. So there's some good. They can always be better, but there's lots of good tests around Tansu, around the protocol in particular. And I've sort of basically taken all those tests and written a benchmark to basically do the protocol testing.
Okay, awesome.
So there's another great tool. The other thing that I like to do is use lots of Rust tools, and there are lots of really, really good Rust tools. So Hyperfine is a great project that allows you to run a test and measure it and come back. It will come back and tell you if it thinks there's other background noise on the machine, and tell you to rerun it until it's got a decent run. So the initial run of my test bench using Hyperfine, it was taking 3.9 seconds to run that test, and then I got some flame graphs as a result of running that.
Could you zoom in a bit, please?
Make it a little bit bigger.
Yeah.
So it's going to be difficult. I might try opening this in a separate window, and then see if we can get to see it a bit better here. So
Okay, this is better.
These are scalable vector graphics of.
Wait, if you're showing me the other tab, you need to focus on it.
Right. No, in which case,
should be there in the browser.
Stop sharing and start again. Can't get the start, can you?
Okay.
Better?
Yeah.
So this is the flame graph, and everybody uses flame graphs now. So this is of the actual test. The cool thing about this flame graph is you can dive into it. I've just gone into the request, but I can go right down to here and look at the timings for each of the pieces. But at the high level, this side is the marshalling of a frame into bytes. So at the heart...
What is a frame exactly?
Sorry, what?
What is a frame exactly?
So a frame is a Kafka protocol frame. So a frame is size, which is a 32-bit integer, a header, and then either a request or a response. And that's what every API request in Kafka ends up becoming. So in Tansu and Kafka itself, it's called a frame, and this is taking a frame and then converting it into bytes. And then this is the trace here where I take a frame of some bytes which have come from the network and convert it back into a frame that Tansu can understand. And what you can see from the flame graph is, what you look for in the flame graph is what's the widest column. Because you're not actually looking at time, you're looking at the number of CPU samples that have happened where this stack frame has been part of the sample. And if it's a wide column, that means it's spent the most amount of time in here. And what this is saying to me, this is the graph at the beginning of profiling Tansu, was that the converting data from bytes into protocol deserialization was the thing that was taking the most amount of time. So I'm mostly concentrated in this area to start with. And you can go through all the different stack frames that Tansu is going through to do this, and sort of look in here, and what you'll see is what Tansu is doing is it's allocating memory. And what you ideally want to do in Rust is when you allocate memory, you want to allocate it once to the size you want it to be. You don't want to grow that memory, because that's a reallocation. And when you reallocate, you have to copy the memory from that allocation to the new allocation, to the new space. And what Tansu was doing was a lot of mem moves, a lot of allocations, all over the place. And they're in lots of different places, not just the stack trace, which is why initially this is only like 2%, but actually on other stack traces it's another 2%, so it actually adds up. You'll also
so you weren't doing that, as you said.
I wasn't doing, so this is the before. And also you'll see that I'm spending quite a lot of time doing a CRC check. So when Kafka receives a batch, a fetch or a produce. It needs to do a CRC check to check that the data is correct or valid. And as you can see here, that the CRC check is taking 3% of the time, which is quite a lot of time. And what you're trying to do at the moment is you're trying to make each of these columns as small as you possibly can, because that then make that column, that bigger column, smaller again.
Smaller, yeah. I see a big difference in how you're optimizing things compared to how I used to optimize flame graphs in Kafka. And it kind of tells me that your program is already very optimized, because back in the day, when I was inspecting flame graphs, if I would see something take 2 or 3%, I usually wouldn't even look into it even more. The issues that we were looking at back in the day was like, one graph was taking, I don't know, 20% or something big like that, like a big, and here we're talking about optimizing 3%.
Because I also know that if I look in here, I'll also find that same allocation.
Right.
So
yeah,
I know, so this is 0.64%. So, but if I add that to the other 2%, and if I go and look, probably in here, this is a mem move there. So actually, individually, they're not very much, but as a whole, and that's another interesting.
No, but that still tells me that there's no low-hanging fruit per se. There's no one thing you fix and boom, 30% improvement. We're talking about like this is 0.13%.
Yes, but the little things add up, and
Okay.
these do add up quite nicely, I think. And although this is the serialization, so this is taking a frame and converting it into bytes. This was in comparison, it's reasonably small. It's only 18% of the sample. I think if I look in here, I'll also find allocations. So this is a great one. This is a reserve, and then a realloc, and a realloc. So actually, I've got quite a lot in here that is the same problem, and that's part of the flame graphs are great. Really love flame graphs, but they're only looking at the same stack, and this is actually ultimately the same call that's happening. And you can use other tools that will highlight this alloc and the mem move as the actual call. So I'm going to stop sharing that. I'll go back to the assuming you'll have.
As a quick question, this test, what was this test running exactly? Was it just producing or both?
But no, a variety. So it does a series of API requests. So that all the ones that I've collected is essentially what the test is doing. The flame graph that you're looking at here is just the produce.
Right.
Because what I wanted to do is narrow it right down to certain API calls, because different APIs calls have different profiles. You wouldn't see the CRC check in a list topics request because it's just not in there. So before we started doing the profiling, it was taking 3.9 seconds to run the test, and that's running 10 runs, and it's actually running 10 times 10,000 times, because each run has 10,000 iterations in it, just so I can get enough samples. Because you want the test to run a reasonable amount of time so you can actually see the differences that you're making.
Wow.
So
that's a big difference.
After the optimization, it pretty much halved the time that it was running in. So these are kind of notes to myself to kind of remind me to do things. So I mentioned that what you want to do in Rust is you want to be able to, in general with memory allocation, you want to be able to allocate the amount of memory you need and then use that memory and not have to reallocate it and move things. Mm-hmm. Well, what Tansu currently doesn't do, I've got a pull request on myself that I haven't reviewed for myself yet, of when it serializes the data, ideally you would allocate the memory to do that serialization in one go. But Tansu at the moment doesn't know how big that needs to be. So I've got a piece of work that's pretty much finished, that when it does the serialization, it goes and works out how big that frame would be in order to do the serialization. And that's more complicated than you might think, because little things like produce requests can be compressed. So you can choose different compression algorithms when you do a produce. The same with the fetch data. So what Tansu will do is it will try and find the maximum that it thinks that would be necessary to do the allocation. So it's actually the uncompressed size that will give you. But the idea being is that it's quicker than doing lots of smaller allocations that grow. There's also
These smaller allocations, they're for parsing the record batches or just next frame?
sorry, say that one again.
These smaller allocations, talking at a low level, what are they parsing exactly? Each frame?
So the allocations are it's the well, I find the protocol quite interesting, as you might be able to tell, but there's a couple of allocations. So particularly when you're talking about record batches, so fetches and produce, there's when we talked about the JSON API descriptors, JSON API descriptors describe so much, but they don't describe the format of the records, the messages that are sent over the wire that are within the batch. And that's a separate document that describes that. So there's kind of the serialization of the frame bit, and there's also the serialization of the record. And they're two separate steps. So there's some allocation that's for the frame, and then there's some allocation that's for the actual batch itself. And that's where I was talking about the compression. Does that make
And the batches are the variable, yeah, and the record batches are the variable bit, and that's actually probably the difficult thing to parse because
Yes.
you can send all sorts of data, all sorts of compression algorithms.
Yeah. So internally, when Tansu is reading a compressed record, it will stream the compression. It won't uncompress it completely. It will just it will uncompress parts and then send that on.
So, so just to make sure we're on the same page then, what we're talking about here is the allocation, reallocation of memory as you're parsing the produce request, as it's coming in the Rust broker, so that you can basically serialize it. No, you can deserialize it into
in a single allocation of memory, yeah, which is the fastest way. I'm trying to think of parallels, but most languages are have managed memory. Like Java has managed memory.
Yeah, this is extremely low level, and you're saying and here in this test you specifically just fixed that, and you have the run from 3.8 seconds was the maximum above to 2.1.
Yeah.
Wow.
Yeah.
That's crazy.
It only says 10 runs here, but it actually the test itself is running 10,000 iterations of each one, so it ends up being consequential.
So this is proper, but I want to also step back and get the high level here, because we can use the whole day diving into specifics and flame graphs. I've done that back in the day too. I've wasted days on flame graphs. But does this matter? It would be my question.
So let's get to hopefully some interesting bits. So I mentioned the null storage. So this is using null storage. It's the numbers I'm giving you here are nothing to do with things being stored. It's purely looking at how quickly can the broker handle a request, is what I'm looking at. I'm using the Kafka producer perf test, which is the one that comes with the Kafka distribution. I'm using a record size of 1 kilobyte, just because that's what I was using. I'm also using localhost, so really it's a test of how fast can I write to memory and how fast can I read from memory. On a Mac Mini M4, I'm sending 600,000 records per second, which represents 585 megabytes per second going through the platform. The average latency, you can see 0.12 milliseconds, and the 50th, not the 50th means anything at all, the 99.9th is 11 milliseconds. The maximum is 91, and I honestly don't think that's right. And the reason why I don't think this is right, so this is the raw data from a 600,000 per second request. I'm using 2.5 million records, and you can see here the 594 megabytes per second. I think I use and you can see 0.2 average. But the weird thing is, and it's only on the first row of each one, it's 92 milliseconds, and it's always around 92 milliseconds. And the weird thing is I leave the broker running all the time because it's a null storage engine, so it's not actually storing anything anyway. So I'm kind of trying to look back at that and try and understand quite why that may be, and it's very certainly probably something I'm doing wrong, but I'd like to understand what it actually is.
So you're showing me that it's 1 millisecond actually. If you go back to the middle rows, the majority of the rows, the maximum latency, is that the maximum latency?
Yeah, maximum latency.
It's 1 millisecond. That's insane.
No, I think it could go faster.
Yeah.
Oh,
So
I definitely think it can go faster because the thing that I'm annoyed about is, so have you heard of iPerf? It's a way of measuring latency on network devices, or rather bandwidth on network devices even. So using on the same Mac Mini, you can run an iPerf server and an iPerf client. I think I should be able to get to 110 gigabits per second.
oh my god.
Because that would then be something that's decently optimized. So that's how far ultimately I'd like to take it, and that will take lots of iterations to get to. But
Wait, that'd be 13.7 gigabytes a second, right? Is that correct?
I love the fact that you can do that in your head. I hope you.
No, it's not in my head. No, it's in Google.
I get confused with gigabits and megabits.
Yeah, I do
And
too.
all sorts of bits. So
That's why I'm translating it. So 1 gigabyte is 125 megabytes. It says.
I'm going to nod and smile. I'm not going to pretend.
Wow.
If I need to do the math, I see it and I do the calculator. One of the things I'd like to be able to do is, I don't like the fact that this is using megabytes per second. I like everything to use the same unit so it's easier to understand. And they're kind of things that I'd like to get done. So I think there's quite a way to go. Well, it needs to happen now is probably, it definitely doesn't need to happen there, but I think that's where it could be. I think that's an interesting facet around Rust is there's no reason that it shouldn't be as fast as a C program that's using localized.
Yeah.
It's a bit different, but it should be in that ballpark, certainly, I think. But the other cool thing is, and I'm trying to be honest about all these kind of things as best as I can. This is looking at the Tansu process, which is the broker process, looking at the resident set size of the program, running on macOS again. That's measured in kilobytes. So I'm turning dividing those kilobytes by 1024 to get megabytes, and I've got 13 megabytes of resident set memory when that was running the 600K. As part of the other thing I wanted to test with the null storage engine was I'm not losing memory for any.
That is insane. Yeah, no memory leaks. That's an insane performance. So you're doing 640 megabytes a second into dev null at a 1 millisecond maximum latency.
Yeah.
I'm assuming we ignore the other roles. With 13 megabytes of resident set size of memory.
I was so unsure about it. I was even looking in activity monitor in macOS. If you can change the columns, you can get the resident set size. That was also showing 13 megabytes.
Wow.
So
these are insane numbers. Sorry, these are insane numbers. But my question here is
why?
How does this? No, not why. Also, well, it's a Rust project, so I think that it's a self-evident answer. But again, does this matter? How does this change once we introduce a storage backend? Because, for example, in Postgres, you're storing each record in a separate row. Surely you hit a bottleneck there, even if you hyper-optimize this protocol parsing.
Absolutely. Part of the justification when I look at myself in the mirror in the morning is why on earth have you spent however many hours trying to get it down to that? Was Tansu is also a proxy. So this is because dev null is effectively the proxy. So how fast can Tansu proxy data is the other thing. Because
that's important.
If you have a proxy, you want it to have as little overhead as possible. This is a low overhead proxy. So yes, it is a little bit silly, but also what I wanted to do when I get onto the profiling of the different storage engines was to be sure that there weren't other things that were getting in the way. And if we're very prudent with the way that we allocate memory in Rust, it will only make the other storage engines quicker. And there were things that I changed. I think there was the CRC check that was in one of those traces that I showed you. I replaced that CLC engine with, cunningly, it was called CLC Fast. And literally it went from, being a however many percent in that trace to nothing at all. I can't even find it in the trace anymore, because it's using SIMD or some other clever thing to do the CLC. So it kind of notes again to myself of this is a baseline performance of understanding where it fits. It can do sub-millisecond latency, responding to several 100,000 requests. It looks like something's capping performance, and I'm not quite sure what that is at the moment because it kind of capped out. The reason why I'm not showing you 700,000 per second because it doesn't do 700,000. It can do 600,000. I don't understand why that is yet, and I would like to understand. So the iPerf metric could be a nice aspirational North Star of where could it be. And that might be in years' time that this is where it is. And the next thing that I'm planning to do is look at performance tuning on SQLite and Postgres.
No, this is awesome. I love this. I love this. It's that, of course, we're diving into such low-level flame graphs and CRC checking and frame parsing and everything. I mean, it's a Rust project, right? It wouldn't be a podcast if we don't dive into this. But now, coming from this low level, I want to dive back out and go into the high level. And I think the proxy is actually a good way to get back to it. So when you say Tansu is a proxy, what's a use case for using Tansu as a proxy? Like, can you imagine me wanting to deploy that? And why would I?
That's a great question. So there's a couple of things there's a couple of spaces in the area that are kind of interesting. One of them is when I've been collecting all this Kafka data, there aren't really good network tools that understand the new Kafka protocol. And what I mean by new is anything beyond the sort of flexible protocol versions. So if you run WireGuard or something like that against a Kafka protocol, it'll show you bits of the protocol, but it won't show you all of it. So one of the interesting things to me with Tansu is potentially taking the protocol layer and dropping that into WireGuard so you can get proper description of what Tansu does, which is kind of not answering your question, but kind of answering your question. So what I kind of see the proxy as being is one of the things that Tansu has is it's got an embedded interpreter in it, an embedded language called rhai, which is a Rust-based language, which it uses from some other things. And wouldn't it be cool if you could have a proxy where I didn't tell you what it could do, but you could write things in a scripted language that's compiled into wasm that could be loaded into a proxy that allowed you to redirect requests for topic X to broker Y. And that's where I see the proxy kind of going to, that it becomes a programmable thing that allows you to do different things with it. Right now, it's something that I use to look at traffic for when people complain about Tansu not doing the things correctly. What I really think it will end up being is something that is a bit like WireGuard, but isn't WireGuard, allows you to upload these little programs that say, pretend this topic exists, or always move this traffic to this broker. And that can be used in Tansu, can be used in any other Kafka compatible system.
Can you say again what that library was called?
Rhai, RHIA. It's a little scripting language. There's a couple of them in Rust, but Rhai is kind of one of the. And I think the other combination that's interesting in Rust as well is wasm, and being able to take bits of language and then these then become plugins into Tansu that just can't be done elsewhere.
And where in the request path do those plugins live?
So there's some really interesting stuff around this. And I'm going to. Do you mind if I show you another blog post?
Yeah, please. Please do.
So this is. Let's go here.
So you're sort of explaining this vision of a proxy with pluggable components, which is a dream, honestly. You're showing the flame graph.
Yeah, I'm trying to get to the right place. So there's some really cool concepts in Rust. Sorry, this is becoming a Rust podcast. There are some really cool things. So this is kind of how is Tansu put together? And the way that Tansu is, and the reason why this is important is because this is how the proxy is also put together, because proxy also shares a lot of what the broker does, but it obviously doesn't handle the API requests. But what Tansu has is it uses, there's this really great concept in Rust. A number of really big projects use this idea of a service trait. And the service trait basically is something that I'm trying to find. Basically, a service trait is something that provides a serve method, which sounds really, really simple. It takes a serve method and it takes the data that you're working on, which in this case is some bytes, and you return a response. And it's such a ridiculously simple concept of just applying a single function, but it's a trait within Rust, which means that you can have multiple implementations of that trait. And what Tansu does is it follows this service and layer mechanism. And what that allows Tansu to do is to layer different bits of protocol differently for the proxy versus the broker. But I can reuse bits of those components. So for example, the client uses the same marshalling code that the broker uses, and it's in the same layer. And Kafka does this as well. It shares all this, but it's a really strong concept within a number of different Rust projects that are kind of network-based Rust projects, and Tansu is kind of standing on the shoulders of that and using this serve concept. So there are a series of services that are composed into layers. So this is a Tansu stack. You basically have a listener layer, a context layer, which tells it the maximum size of the frame that it's allowed to accept, then something that takes TCP and converts it into bytes, and something that takes bytes and converts it into frames.
And this is how composable in a way because they use the same interface.
Exactly, and that's the concept that I'm trying to get across here, is that one of these composable layers could be a proxy layer that uses a scripting language to decide what to do.
Right, so you can implement that service interface again.
Yeah. So, for example, it's a while since I looked at this.
Okay, so the code, you're basically telling me that the code is extremely composable.
Yes. So, for example, here, what I'm doing is I'm building things up, and I'm saying anything with this key, so a metadata request, I want you to basically use the metadata service. And this is how the broker composes all the different API requests together.
Wow.
And that's
beautiful.
Literally, this is a function within the broker called metadata, and it allows you to build these layers up and allows you to, sorry for the very loud ping. It's my wife saying that she's sorted out my mother's Christmas present.
Very last minute. Recording a few days before Christmas here.
As it was last year. But what I'm trying to get across here is that the whole idea of these layers and services is that Tansu is this very composable thing that happens to be a broker. But it can also be a proxy, and those layers could include something that looks at the incoming request and says, oh, it's a metadata request. I will run a script that is a metadata script, and that script then tells it to redirect that to a different broker.
I love the code, by the way. This is beautiful code. But then you're telling me also that so other implementations, not implementations, but use cases of a proxy could be, you can implement, for example, multi-tenancy. Mm-hmm. You could parse specific parts of the request, add a prefix, let's say, this is tenant A, etc.
Authentication, all the security side of things.
You can filter things out as well.
Absolutely.
So I think we have some of these features with popular Kafka proxies today with, I think at least Conductor. I really like what they were doing with the proxy. I really think that Kafka needed a proxy, and it was an underinvested area, because a proxy basically allows you to sidestep limitations of the broker. So if Apache Kafka says, hey, we don't want to do schema validation because it will kill performance, some users and some customers will say, well, I don't care about the performance. I'm only pushing 1 megabyte a second. To me, validating my schema is way more valuable than shaving off, let's say, whatever milliseconds. So with the proxy, in theory, you can add that without changing the core broker code. And it seems you're kind of saying that in the future, one path is to just use Tansu as the Kafka proxy, the super performant Kafka proxy, and you implement some logic on it. It goes to wasm. It's basically the lowest performance thing you can have as a proxy.
Absolutely. So the part of the sort of concept we were talking about earlier was I really like the idea of keeping the broker as simple as possible. So you could quite happily argue that I shouldn't have done schema validation in the broker, and I probably, on certain days, I'd probably argue with you, and other days I'd probably agree with you. I think it's kind of 50-50 as to whether or not that was a good idea. Yeah. Part of the motivation around the proxy was just for me to be able to capture protocol traffic easily. But the other motivation was, we mentioned S3 earlier, and one of the issues with S3, certainly from Tansu's implementation of how S3 is done, is it's very reliant on the clients batching records together. If you have a client that just sends single record, single record, single record instead of batches, each one of those on Tansu ends up being a put request, which ends up being dollars in AWS's wallet.
Big dollars.
Big dollars. Well, wouldn't it be nice if there was something you could stick in front of Tansu that batch those requests together for you? So it doesn't matter that the client isn't behaving very well, you can do the batching. And that's part of what the Tansu proxy does right now, is if you've got a client that's doing single requests, what Tansu has is a proxy that will sit there and collect produce requests, put them all together, and then forward them to the origin Tansu broker.
Right.
So rather than having a dozen put requests, you end up with one put request.
Mm-hmm. I think this is a good segue into the S3-based Tansu. So as far as I understand, what you just told me is that you have a very severe limitation in the S3-based Tansu right now, at least without using the proxy per se. The key thing that services like WarpStream, diskless topics, and Kafka and all of these use is they batch the data in the broker, because the S3 cost is extremely sensitive to the number of put requests you do. So as a simple example, if you're batching data up to 250 milliseconds and doing one put, if you're receiving, let's say, 250 requests in that time, and you just naively store every request, not only does the latency probably goes up as well, but also that's 250 times more expensive.
Yeah.
I actually created a calculator about this once that sort of did this batching. Let me see if I can pull it up. That did this batching calculation. Basically, it said, okay, how many megabytes, under what megabytes a second and what batch time do you actually end up being cheaper than regular Kafka?
Yeah.
I.e., in what case does the put request cost less than the replication?
Yes.
And let me see if I can show this really quick again. But I found that that's maybe somewhere around like half a megabyte from what I saw, compared in AWS at least. So as you can see, this, I think that this is a limited tool. It only compares replication to the put request, so it ignores some other stuff. But here, if we're using a batch interval of 300 milliseconds, and there's also a batch size, which is the lowest of these two. Whichever gets hit, that's what gets put. But for this use case, we don't really care about the batch size, so let me put it to the max. But if you're receiving, let's say, 0.43 megabytes a second, and you're batching that data every 300 milliseconds, meaning every second you're roughly doing 3 S3 puts, the Kafka cost in AWS, the classic Kafka cost to replicate, is what you would receive as 0.43 megabytes a second in classic Kafka. That cost would be the same as if you were using something that writes to S3 and batches that versus regular Kafka. And if we increase the batch size to, let's say, a second here, you see that, okay, the cost is actually cheaper now to write to S3. So the megabyte equivalent is 0.13. And this tool basically tried to answer the question like of, if I have this configuration, at what point does it make sense to actually use diskless topics or use something like warp stream? And it sort of proves that, okay, if you're using, let's say, less than half a megabyte per second, you don't really need to write directly to S3. And then I also handle the cases where, depending on the cloud platform, who charges differently for networking.
Very cool tool. Very cool tool.
Yeah, thanks. So from that point of view, talking back about Tansu, if you aren't batching most of the times, it will actually end up way more expensive than classic Kafka. So what was your thinking then when you made it naively just store every pod? Is it you're just not focused on S3, it's not the highest priority, or you think that the proxy thing is easy to set up and it's a good model, good architecture?
So the first one was, what is the simplest thing that can work? Was kind of the North Star there. And
okay.
Again, trying to second guess how people are using things is difficult. So are they using S3 at a low volume, or is it S3 at a high volume? And if it's low volume, then what I'd originally done in Tansu was kind of, it made sense. And also in the back of my head was, I really want to keep the broker as simple as possible. Didn't really want the broker to do batching. I wanted it to be able to send data directly at that point. So the idea was, and the other reason was, is this isn't just to do with S3. It's also to do with Iceberg and Delta, because both of those systems also have an issue with small batches. And what I wanted was something that did both. So the idea of the proxy wasn't actually anything to do with S3. It was actually from people using Delta Lake wanting to do batching of records, so that instead there was a single batch going into Delta Lake, which ultimately was also an S3, but it just reduced them. These small batches within Delta was the actual motivation. So the proxy works for both S3, and it also helps solve, at least partially, the small batch writes of both Iceberg and Delta.
But what batches are we talking about, or what milliseconds?
Anything that is a produce that goes into Tansu, that is a schema back topic, can go into S3, which that could be multiple put requests if it's a small batch. So it's kind of addressing that and kind of batching together requests and then making a single request to S3. But also it's true for if you want to use a different storage engine, so Postgres, let's say, but you also want to write that data into Delta Lake or Iceberg. It does exactly the same thing and batches together lots of small requests until you have either the size that you've asked it to batch up or the number of records. It'll do either of that, and it will then send that single batch to Tansu, the broker. It will then do a single request into Iceberg or Delta.
So my understanding is for Iceberg particularly that the recommended file size is 256 megabytes, and let's say you do something reasonably smaller than that, like 50 megabytes, etc. That's why I'm asking, how big would the batch actually be in this Iceberg case? Because even if you batch it, let's say for 300 milliseconds, that still feels like it's an order of magnitude not enough for what Iceberg wants.
But it's still better than doing the individual batches. It's definitely not.
It's not
a 256 megabyte. I hadn't heard the 256 megabyte before. I've used smaller batches than that, but it's particularly on Delta Lake that I was looking at in that case. So we got pretty good performance out of Delta Lake with it doing the batching.
Do you remember the exact batch sizes or rough ballpark? I'm not aware of what Delta Lake.
Probably if I just run the tansu command, it's whatever the default is on that.
Okay.
Because that's usually where it ends up. Target profiling tansu proxy.
But you're saying it worked fine when you did some tests.
It works to the level that it doesn't actually look like.
Because both of these protocols or both of these specs are not made for streaming data in general. So I think what we're sort of aiming at here is just to not be completely disastrous, and then later you can compact the data on the back end of these icebergs. of these table formats? I mean,
What Tansu does is it writes into both Iceberg and Delta, and it uses Kafka record batches, and it will batch those up if you're using the proxy. And then what it will do on, I think, both platforms, if I remember correctly, it then runs maintenance, a bit like the compactor that Kafka already has. What it does is it runs maintenance every 10 minutes or whatever you've configured it to be. And what that does is the record compaction. So it will take all the Parquet files that you've put together and then compact them. So you're absolutely right that it's writing lots and lots of small batches. But the idea is that you then compact them once they're on S3. So you are paying the charges or wherever you're deciding to store the data. But Tansu will run compaction against, so each storage engine has a maintenance callback, which, for example, the Postgres storage engine, it uses that to delete old records and to do compaction. So that runs every so often. But what it uses with the Iceberg storage engine is that, and Delta, it will run maintenance on that topic. So it will compact together all Parquet, so it's a single Parquet file, or however it's configured to compact. So
wow, that's super
I'm
cool.
not sure I've answered your question. I've kind of moved around your question a little bit. But the idea of the proxy is that it kind of batches things together at the start. Is that small enough to answer your question? Probably not. Depends on the data, doesn't it really? But what it then does do is every 10 minutes or whatever you configured, it then runs maintenance, which in Iceberg it will then collate together the Parquet and put them together into your 256 megabyte files.
And I love your honesty if you've answered my question. I love that. You make interviewing really easy. But that's super cool that you have compaction then in Iceberg handled and potentially in Delta Lake. A quick question that came to my mind then is how do you handle reads if the write directly goes into an Iceberg format? Aren't reads expensive in that case? Before it gets compacted at least.
Do you mean Kafka fetches? Is that what you're...
Kafka fetches, yeah. Kafka
there
fetches.
are... Tansu has this idea of sync topics. Probably not brilliantly well formed, but it has this idea of sync topics. And what it does with the sync topic is it writes almost no metadata. It basically has to store the last offset that it saw and sequences if you're doing idempotent producers, that kind of stuff it's storing in the S3 metadata. Everything else it's storing into either Iceberg or Delta. The key thing about those sync topics in Tansu is you can't fetch from them because I'm not duplicating the data. So there's nothing really to fetch from. And I didn't think it was great to go to Iceberg to try and do a fetch and convert things from, because obviously it's in arrow at that point. It's in the columnar format. You've got to then convert it back.
Yes, yeah, it's very complex.
In memory. It's not too bad, but just the whole process of fetching something from S3 to then convert in from columnar format back into row format to throw 256 megabytes of data just to give you back one row.
Yeah, exactly. It's backwards. So in a sense, then this sync topic primitive is just something you want to sync into an Iceberg and kind of forget about it. So how would you then implement? What if I wanted both? What would you recommend I do? I run a proxy or replicate a topic, or what's the?
So Tansu has this topic configuration, which is I think Tansu sync equals true. So it uses topic configuration to control this.
Awesome.
If you have Tansu sync as true, which was another reason why I ended up writing the admin client stuff, because the annoying thing about the Kafka admin client is if it's not on the list of parameters, you can't add new parameters. So that's one of the reasons why I ended up writing the client.
Nice.
But basically, if you don't supply that sync, Tansu will do a double write. So it will write the Kafka data as it would normally write Kafka data, and it will also write to the Iceberg or to the Delta Lake. So
if you don't have sync on the topic enabled, but you have Iceberg enabled on the Tansu level. And do you enable Iceberg at the topic level or at the broker level?
So at the moment, there's a couple of big assumptions that when you start the broker up, if you don't specify either Iceberg or Delta Lake, it won't do anything to do with any data lake. which also means that Tansu only supports one type of data lake at a time, which I'm hoping that companies aren't doing dual at the moment, but if ultimately it needs to be both, then I'll have to make it an option rather than a subcommand. So you have to run the broker in a specific mode in order to enable data lake functionality. If you don't want data lake, you don't include it as a feature in the binary when you build it, so you get a much smaller binary anyway, and you just don't supply the option.
In this data lake option, does it have to be on S3, or can I, like, if I have Postgres configured as a backend, what happens then? And I enable Iceberg.
So you're reliant on what Iceberg or Delta Lake supports. So I think Delta Lake you can write to the file system. You can probably write to the file system in Iceberg. It's been a while since I've tried anything other than S3. But with Iceberg, you'll certainly need a catalog running. So you'll need a REST-based catalog, which Tansu talks to. And Delta Lake's, I get the impression Delta Lake's a bit more like the way that Tansu works. There's no catalog that needs to run, and it seems to use conditional writes, very much like the way that Tansu works. Just from the way I've observed how it's writing into S3. So I think probably the answer is yes to your question, that you could write to the file system if you wanted to.
Isn't Tansu also an Iceberg catalog in that sense, or how does otherwise the compaction work on the Iceberg side?
Because Tansu is talking to the Iceberg catalog and saying, compact this for me. So it's talking to Iceberg and it's talking to the catalog and saying, given this table, compact it.
But Tansu is doing the compaction, right?
Tansu is making the request for the compaction to happen. Yes.
Oh, okay. So that compaction logic must live in the catalog, which I'm not sure if the catalog API actually supports compaction per se.
I'd have to check and see which is which.
So something like S3 tables supports compaction.
Yes.
And it must have an API for it.
I keep on wanting to look at S3 tables.
Because from what I remember from the Iceberg spec, and I very well may be wrong here, is that compaction is actually done on the client. So something like Spark, let's say, it's the one that implements the compaction of changing the files and persisting the new ones, and just talks to a catalog to sort of understand.
So just so I can be really honest with anybody and everybody, it's so much easier than not being. Let's go here. Can I only share things that are part of? I know window. Can't get the start, can you?
We're gonna look at some code. I'm excited.
Yeah, it's much easier because
yeah, for sure.
The honest answer is I can't remember. The simpler answer is to show you. So, what's some cool stuff around this? So, this is great. Instrumentation is just a macro in Rust, which is really, really neat. So I can measure how long this function takes. And what this does, this is the Delta Lake storage engine. It's not really a storage engine, but you can see it's calling compact on the table. So Delta Lake definitely supports compaction. And I'm just calling that through the Delta Lake API.
You're right.
This big one is
Burk.rs, it seems.
Yes.
Yeah.
Oh, well, there you go. So there's no.
Okay, so it's not implemented. Got it. Okay.
That's the easiest way to tell you.
Yeah, awesome. Yeah, awesome. I love that.
The reason why I think that's the case is because I think it is down to the catalog how that's configured and actually done. And I do think it is Iceberg that's the catalog side of things that's doing the compaction.
Yeah, it's complicated, I think. That ecosystem is complicated to me. I think not necessarily because of any inherent complication, but I think the documentation, the amount of amount of words, amount of definitions is confusing,
there's a lot
especially
of specs
to someone
in that space. Yeah. But it's, certainly on the Delta Lake side of things, I do compaction, and then I also do Z ordering of. So you can partition, and then you can have further subpartitions, which I is what the Z ordering is.
Can you open the compact method?
No, because I can, but it's just going to be what's in Delta Lake.
It's in some library, right?
Yes, it's in delta.rs, which is, it's another, back to your why on earth are you doing all this, and it's kind of, there's this huge, excuse the pun a little bit, huge confluence of really cool things that are going on in Rust. One of them is Apache Arrow. One of them is, and all these things like Data Fusion are all Rust projects. I know they're also Java projects, but a lot of driving is coming from Rust as well. So there's the key difference between what I was doing in Erlang was that there's kind of nothing in that space.
Yeah.
Whereas in Rust, how long did it take to do Delta Lake? Not very long at all, because the Delta Lake implementation is not very many.
It's not too big.
It's not that huge. I mean, it's probably quite a lot of duplicated code from actually the majority of it's tests. Look, I was talking about tests earlier.
Oh.
Here are tests. I'd forgotten that we had lots of tests in here.
That's in the same file. Interesting.
So yeah, so the way that Rust breaks these things up is that you write integration tests in a separate file, in a separate directory, and you can only use the public API of the crate when you're doing those integration tests.
Yep.
If you want to do unit tests, then you put them as part of the actual. So actually, yes.
Oh wow.
Yeah. So
700 lines of code only.
Implementation is only 700-ish lines.
That is crazy.
So the config test is basically conditional compilation within Rust. So when you build the binary, these tests won't be part of the binary, but they are run as part of the unit tests.
I love how you're thinking about that. But that's amazing. That's an amazing feature of Rust, of how you're just able to use these libraries and sort of piggyback with minimal implementation, minimal work.
Standing on the shoulders of giants.
Yeah.
That to me is that's the more compelling thing of being able to get the Kafka API together as a thing, and then working out how can you also exploit and use things like Delta Lake or Iceberg or Data Fusion or the Postgres wire protocol. There's so many things in that space that are really interesting. Completely on a tangent, which I apologize, I do far too much. There's some really cool things around Postgres that Tansu doesn't do that I'd love it to be able to do. One of them being a client of the replication stream. So Kafka at the moment, when you do a fetch, you're basically doing a poll. Wouldn't it be really cool if Tansu knew that there was new data in the database that another broker had produced, and it's using the replication protocol for that data to be pushed to Tansu for it not to have to query the database?
Oh my, that's CDC without basically being CDC, right?
And all the PGY stuff is there in Rust, and it's there's some really great people that have done their work already, and I think there's some really, your kind of question of how does this go, and I think those kind of areas of making it Kafka more of a push system is also an interesting space to be in, where you can still do the long poll that it's always done, but the way that Tansu works at the moment is it does a long poll to the database. If there's no data, it'll do a query to the database. If there's no data, it will redo that query in a second later or however long you've asked it to do it. It would be really cool if instead it could say, well, actually, I'm interested in this table. Please tell me when there is data, and then respond.
That's super interesting.
And I think those things are possible, certainly with Postgres, and basically creating a replication client and saying I want to create a publication that is just the tables that you're interested in.
Yeah, the world is your canvas when you open up the possibilities of the API. In that also you said you're standing on the shoulders of giants, but the way I'm looking at Tansu can also become a giant itself in that it can be an embeddable Rust library. Is that true?
Well, it'd be very nice if it did. It would be very nice if it did. I mean, I think it's always interesting, speaking as a solo developer, solo founder, it's always interesting. That whole creative process of building something, developing something, publishing it, getting feedback, good and bad, is always interesting. And it would be great if Tansu found a space, small space in the Kafka ecosystem. Um, maybe it never ever becomes the broker. Maybe it becomes the client. I'm kind of I think it'd be great if it was the broker. But even if the best that we got out of Tansi was much more available client that we could use by different programming languages like Python and have a sort of stable API that they could use, that would be a great outcome. Um, but if it became a sort of embedded broker that you can now use Kafka in places where you didn't think you could use Kafka, that could be quite interesting. There's probably not too many IoT devices that are running Python that need a Kafka client right now.
Yeah, I love that. I love the possibilities of this project. I I really love the way the whole thing is going. I also love your editor. You opened my eyes. This is Z, right?
Bedrocks.
I adore Z.
So
It's such an awesome.
I'm a an old greybeard, as you can probably tell, and I've used Emacs for probably 30 plus years. I've been using Z for the last 2 years and haven't gone back to Emacs after 30 plus years. It's written in Rust, so obviously it's very cool. But it's really really fast. The guys behind it are really really clever, and it's really
They're awesome.
yeah
No, I read a lot of their blog posts as well. I love the culture they have and the
yeah
vision they have for the editor.
yeah. So it's very much a Rust sort of project, and everything I'm trying to use around it is like Hyperfine, which I'm using for all of the sort of profiling to do the measurement. There are so many good tools in the Rust sort of space that are really neat.
The Rust ecosystem is fascinating. Um, so I want to segue now into the discussion of broad use cases of Kafka. And we talked about the OLTP case, which is what you developed in that company with the trading and everything. And now we talked about Delta Lake and Iceberg, which I think cover more of the OLAP case, which is, if I can separate, I would say, OLTP is stuff you want to react to immediately. And the computer reacts to it immediately, and basically that forms the business process of, let's say, executing a trade or matching orders or etc. Whereas the OLAP is more like you accumulate some data in some place, be it a data lake or something, and at some point in the future, either a computer program or most likely a human runs some large-scale analysis. So they would see something like, okay, what are the trades that our business has done over the last 30 days, over the last 10 days? How has that trended? Let's perform some aggregations. And I think so those are the two use cases I would kind of split Kafka between the OLAP and the OLTP. And there's also, I think, a third one that doesn't map super cleanly. I would call this the telemetry use case, which is all my applications, microservices, etc., are producing some sort of telemetry data, be it application logs, so like info logs, program did this, debug logs, or just metric data points. This can be in a specific format like OTel, it could be your own custom thing, but that type of data also gets plumped to the system, into some other downstream system where, again, most likely a human is going to be the one that analyzes that, but there's also programs on it. So first, do you agree with that like three-way split of Kafka before we go deeper into it?
Yes, I think broadly. I mean, it's difficult to put real firm categories around it, but I think broadly that makes a lot of sense. I mean, the human is obviously using Excel to do that.
Yeah, so Kafka to Excel. But and from your experience in Kafka, you said you've had, I think, 10 years of working with Kafka. How would you split the percentage base on that in terms of the companies you worked for? What do they focus on? What do you think is more common in the world?
It's difficult for me to say because I worked in one, I think, quite specific domain, and it was probably guided quite a lot by what I thought around the sort of event-based processing model. So a lot of what I was doing in particular together with teams that I was working around and with was very much a transactional type thing. So these things have happened. Can we produce a recommendation for that customer? And that recommendation needs to happen in low, ideally milliseconds, but no more than seconds, because it's very ephemeral in terms of what's available. But there were certainly other teams that I wasn't directly involved with that were taking those streams of data and aggregating them and putting them onto Kafka to do the aggregation, using Spark and other tools like that to produce those kind of views of the rolled up view of this data. What has this customer done in the last 3 months, the last 6 months, those kind of things.
And when you think about the vision of Tansu, is there any one particular case you wanted to excel at, or would you like to support all? Do you not care?
I don't think it should massively matter to Tansu as to what that use case is. The one thing I'd probably say is the kind of focus that Tansu has around, maybe the SQL storage engines. And I don't have a lot of experience storing, that kind of a large data set, as in single messages that are, megabytes in size. Maybe that isn't the right place to do it. Postgres has a mechanism of doing it, which I've forgotten what it's called, but it allows it to store extremely large columns, measured in the tens and hundreds of megabytes.
That's Toast.
What's it called?
Toast, I think it was.
Yes, I think you're right. I haven't tested those things out, so maybe that isn't great in Tansu right now, but it's certainly something that could be. But I don't think, I'm trying to be as neutral as possible. As far as I'm concerned, Tansu is a broker that implements the Kafka API. It's developer focused because I think it's kind of interesting to be in that space anyway, and it allows people to sort of experience the kind of ease of use there. But there's no reason that couldn't be a data engineer that's developing large data solutions. It's just probably not so much of my background.
Makes sense. I'm asking because you showed me Delta Lake and Iceberg, and that's more of the OLAP layer. I'm not sure how widely used or applicable it is for OLTP data to be synced directly to Iceberg, for example.
So that was originally, Iceberg was kind of, can't remember what the incentive was to do Iceberg. Certainly Delta Lake was some initial feedback pretty early on from some people who wanted Delta Lake support. And to me it kind of makes sense, because you can kind of it kind of makes sense as a whole, particularly for Tansu, because it does have this schema validation. Mm-hmm. And I think that particular use case, they were very heavily into protobuf. And companies like that, they tend to cut through them, and they are protobuf to the core. It's kind of, everything is protobuf. So it kind of made sense to them. And that's why the batching in the proxy sort of happened, because it was kind of handling the volumes that they were talking about.
I mean, when you saw that 700 lines of code to implement Delta Lake, you're like, of course.
So what it wasn't showing you is that the code that is that converts it into Arrow, which is both Iceberg and Delta Lake do it the same way. You're ultimately writing to Parquet. There's minor differences with Iceberg. Iceberg needs a field identifier that Delta Lake doesn't need, but essentially it's the same code. So once I'd done Iceberg, it was really easy to do Delta Lake. It was 600 lines of code and 200,000 lines of tests, or whatever it was, or 2,000 lines of tests to kind of check those things out. So it just, if I can do Iceberg, then why not do Delta Lake? They're kind of one in the same.
Awesome. And so you said somebody gave you feedback. Does anybody use Tansu today? Maybe not necessarily in production, but do you have people running it, testing it? What's your pulse on the ecosystem so far?
It's hard to give you an honest answer to that isn't just sort of a little bit of speculation. because it's open source, people do download it, people do use it, however you want to define use it. I've certainly spoken to a group of people who are using it right now. That's in a pre-production environment, but they're very happy with what they've seen. And hopefully that will end up in a production environment. I spoke to one group who their first comment to me was, "We've been in production for a year," which really confused me because I didn't think it was possible to be in production for a year. But anyway, and I'm not sure what volume that is. It could be tiny or it could be bigger. But certainly there's more and more. Thanks to you and some of the publicity that you've absolutely been very helpful. Thank you very much for it. It's kind of helped raise the profile of it, so more people are looking more at using it. And if people are using it in production, then please reach out and say hello.
Yeah, I'm looking forward to raise the publicity a lot more because I think what you're working on is extremely interesting, and I see no reason for it to not have a lot more use. I think it's just publicity that's limiting. You are very talented. It appears to me like the amount of breadth of knowledge you have, but also depth. From low-level optimization to supporting different sort of protocols and everything is seriously impressive. So, good job on you in general. Like my kudos for this project.
Thank you very much. Only my mum says things like that normally.
And you're one person behind this whole thing, right? You don't have a team.
That's right. That's right. And I kind of, it's good and bad. So I have the bathroom conversations in the mirror in the morning. And you kind of talk to yourself about, what are you going to do today, this morning, Peter? And it's going to be, what is the consequence of this and why? And why have you spent the last week really optimizing those things? So sometimes it's part of it's the difficulty of how do you focus, make sure you're doing things that are right, that are useful. And part of that is feedback from the community, which getting more of. But I'm really interested in the space, and I think it's a really interesting time to look at what Kafka does, respect entirely what Kafka does. I think Kafka's amazing, and then look at how Kafka could be done differently. That isn't necessarily a LinkedIn type thing. It's a different kind of thing, and that's based on the experience that I've had of running Kafka in production and writing different platforms in Kafka. It's all those things sort of combining into what I'm interested in.
Yeah, because you basically you're wearing a lot of hats. You're wearing the product manager hat of figuring out what to do and why. You're also wearing the marketing hat, so you have to represent the project and talk about it. You are obviously engineering the whole thing, which is the work itself. It's crazy. It's crazy how much it is, but you enjoy it.
I massively enjoy it. I've been in this. I'm in this office from usually 7 o'clock in the morning till about 7 o'clock at night because I enjoy it. I really like the whole process. I love the whole process of programming, the process of writing programs. That whole thing is just, to me, that's how I relax.
I love that. That's awesome. It's really awesome to see you in your element, so to say. Before I ask more questions about Tansu, I want to ask you what you're most excited about in Tansu, or not necessarily what you're currently working on, but what are you looking forward to? Let's say in the new year, especially as we're closing this year out now.
What am I looking forward to in the new year? Oh, that's an interesting question. I think part of an issue is not thinking ahead like that. Is quite an interesting one. So, what would I like Tansu to do next?
Well, that's a fair answer, by the way. If you're not thinking that long term, it doesn't have to be for a year.
I think what I'm looking to do at the moment is make sure that it's So, for example, I've got there's an issue raised on GitHub just in the last week, and somebody's tried to use a Kafka client that I've never really used before. Don't have a huge amount of experience with it, and I'm protocol compliant. I'm responding in the right way. I'm responding in the same way as Kafka responds, but the client isn't working in the same way. So I think what I'm most interested in doing is being Kafka compatible and properly doing that. So you can properly drop in Tansu and it will just work. And I think there's quite a lot of effort in getting that to actually work, because it's not just returning the same response. It's this sequence of responses. So this particular client, they've got an optimization which I don't really understand, which this only seems to be triggered by the I don't support all of the APIs. So, for example, they make a request to us for the ACLs for the topic. I just say there are no ACLs, and it's a different response. I suspect it's kind of thinking that it's talking to an older version of Kafka than it actually is. So it's making slightly different requests. So I guess the long answer to your question is doing the proper engineering to make sure that Tansu is properly compliant with any client, any random client that you find. And I think that's quite a difficult thing to do, because as we sort of spoke about earlier, there's no real quality control or gates to those clients. Some of them are using the Java client, but there's lots that are using lots of different clients. So working on the protocol compatibility, making sure that's good, and then tuning the other pieces. So there's the piece of work that I did on the null protocol engine, the null storage engine. I can show you some figures for SQLite, which are kind of interesting and kind of nice. But to be honest, Postgres there, I'm still tuning. And so I'm looking forward to getting the Postgres one as good as the other storage engines. So it can really have a good story across all storage.
Okay, interesting. So basically, if I can summarize that answer, it's beefing up Postgres to be on the same level of SQLite support, and making yourself Kafka compatible in the truest sense, which you already are, but of course, it takes one client to break that. But that second part, that comes with time, as I understand, because I doubt that you would go ahead and spin up every possible Kafka client and run every possible.
No, so that is somewhat to do with feedback from
Right.
people using it. So I have a variety of. One of the nice things is, so everything is public, which I kind of like. It's kind of, there's nowhere really to hide. So I do, as part of the build process of Tansu, it's quite long. You might have seen it's like 2 hours to do a build, which is annoyingly long. But part of that is a smoke test. So it runs the Java client against Tansu at the end of every bit. Well, it's actually every pull request, anything that causes a new build in Tansu. It runs smoke tests against Tansu. So I've written some bash automated test scripts that basically allow you to run tests against Tansu, and I would intend to increase those to cover more clients. So the Python client, the JavaScript client. So I can basically reassure myself that if I make any change to the platform, that it's not going to impact the clients down the line. So probably beefing those things up. I'm very into the testing side of things, so I actually get more satisfaction out of writing good tests than most other things. I was very lucky very early in my career. We ended up working for a company, and we hired Kent Beck of Extreme Programming fame. We had him as a consultant on our group, and that kind of completely changed the way that I wrote software. Because the whole idea of testing and is just very much ingrained in what I do. So around that, I think it would be interesting to get really good tests in place that cover a lot more of the clients and cover a lot more of the edge cases.
Interesting. Okay then. Yeah.
It's a big thing, I think. I mean, to say you're there's no institution that says you're Kafka compatible.
Yeah.
I'm
No, no.
Kafka compatible, but I might not be at all. And there's
It's
no.
a
So it's an interesting one. I mean, there's all sorts of Kafka tests within the Kafka project, but I don't think they're. I've kind of half looked at them and thinking, well, could I run those tests against Tansu? And I think probably the answer is mostly no. But that's kind of where I'd like to be able to get to. I'm thinking of kind of in the Java space and the J2E space and those kind of spaces that some would produce compatibility test suites so you could actually say you are compatible. And I think that's an interesting space around Kafka as to how do you actually say you are Kafka compatible.
Yeah, I've heard this idea before. I'm trying to remember where from, but I think somebody else was talking about making the spec more official and formal, because today it's kind of bundled into the broker, but with so many different implementations, we get value from actually having it be its own separate thing. I think we will get there inevitably, next, let's say, 5 years or so, as this development continues to ramp up, and that's something we've definitely seen. We've seen a lot of alternative Kafka development in the last, ever since WarpStream, honestly, since 2023. I'm not sure where the future is gonna go, or the focus is gonna go, but the diskless Kafka topic is the new thing being developed right now. I mean, it was already developed proprietarily, and now it's coming into the open source with the diskless topic skip, which hasn't yet been accepted, so that's kind of up in the air, but I think high likelihood it does get accepted. And one of the key things that diskless topics does is it enables Kafka to be flexible in that it would support both classic topics, which from the point of view of a user are low latency topics, and diskless topics, which from the point of view of the user are high latency topics, but much cheaper ones. And with Tansu, you support, again, many backends. You support SQLite, you support Postgres, you support S3. And S3, if you want it to be of the diskless type, you probably need to run a Tansu proxy in front, so it batches. How are you thinking about diskless topics and the idea to separate topic latency within the same cluster? Do you think that's valuable? Do you think that's something you want to do in Tansu?
To be honest, it isn't something I haven't thought a massive amount around things like the new consumer or diskless topics, because I'm kind of, I guess, looking a lot at what existing projects that I know were running, and what they would benefit from, which was kind of the ideas around sort of, I haven't implemented some of the new stuff. Maybe if people start asking for it, then that would be a good draw.
That makes sense.
So I'm not sure if that particularly answers your question, but
it's not focused. You're not focused on it right now. No, I think that's a very fair question, fair answer, because you are one person. You only have so much time.
Yes, give me a break. Come on.
Yeah, so you have to do what you know is valuable, at least, and the rest will come from the market.
I get. Yes. Yeah.
But then, what do you want to support? Like SQLite, Postgres, S3. I even saw an issue in the GitHub saying potentially support SlateDB as that new database. It's S3 compatible. So, do you think that saps energy away from you, or sort of like being a master of all trades means being a master of none?
Oh, that's a lovely question. I'm very happy to take that as a criticism. I think. Yes, that may be true. Things that I'd quite like to do. No, let's upgrade that. That's probably true. Why do SQLite? Everybody uses SQLite, so why not get something running on SQLite? The S3 and SlateDB. I think SlateDB is really interesting in terms of it's another way of batching requests together. It has disadvantages that it's a single writer, but the way that it does single writers is that you can partition. So you can basically say, this single writer is just going to do this topic, this single writer is going to do this topic. So you could use the proxy to kind of split the writes. The other thing is, I don't think it's going to take very much effort to do SlateDB, which is another reason. It's another just put and get. With a scan, it's potentially the way that we talked about puts and gets, but we haven't mentioned lists. In order to tell you what topics that you have, I'm doing a list in some cases to look up offsets. They're quite expensive to do as well. So potentially it'd be another way of not having those requests happening. So it could be cheaper. But I also, part of what I'd quite like to do with Tansu is do some experiments like, what is it like with SlateDB? What is it like with another larger store and see? And they're hopefully not things that take 3 months to do. They're hopefully things that take 3 weeks to do. And you can kind of see at the end, is that a good way to go?
I think that's a great answer because even to play devil's advocate to my own question is you don't need to be a master of one trait necessarily if you're not aiming to dethrone, let's say, some incredibly high performance systems infrastructure. It's, as you said, focus on 80% of the users. And when I wrote a blog post comparing Kafka to Postgres, just using plain Postgres, I made the point that, for a lot of use cases of Kafka, you can actually just get away with using a database, even though it's the wrong data structure, it's not optimized, it's just not made for this. It still works fine enough because the hardware is forgiving and your use case is so small. So from that point of view, even if Tansu supports, say, 10 backends, if you're not really trying to squeeze out every inch or every inch of performance out of that backend, that still works. And I like your answer of still experimenting and keeping things light, because it's hard to have, when you start with a single vision and you bet everything on it, you can also very much fail spectacularly and then you miss everything. But if you start supporting a lot of backends, you're sort of hedging your bets and you're opening sort of your ears up to the market to see, okay, I have all these ideas, let's see which one of these the market wants the most, and potentially you focus more on one. Once you see traction, potentially you support them all.
Absolutely. Yeah.
It's very path dependent in that way, and you can't necessarily predict the future unless you're some visionary. But again, 99 out of 100 visionaries get it wrong anyway. So I like how you're thinking about it. And again, it's worth stressing this project is only a year old in publicity.
Yeah. I massively agree with you. I think there's a lot in the sort of product management space of you need to be this huge visionary of this and that, and finding product market fit is a large part of that as well. And I think SlateDB, I put it, it's kind of, how can I get people interested in this project? Well, I was talking to somebody who was working on another project, and it was like one of the best things that they did was started putting help wanted on pull requests on issues. And SlateDB was exactly that. I kind of started a bit of it, put a help wanted, and somebody very luckily pulled up a seat and said, yeah, I'm interested in helping there. I think there could be other ones in that space as well. There's another colonial database that would be really interesting to do. I'm not sure which one, but I'm sure there'll be one in that space. And I think the other thing I've toyed with is having storage engines that are not really part of Tansu. That somebody else could build the storage engine. There's the API that is there, and you can plug the storage engine in. So if random database company wanted a storage engine for Tansu, they could write it, and as long as it conforms with the API, it could just be plugged in. So it doesn't just become, Tansu just becomes a broker that can use many different independent storage engines.
Yeah, that's an interesting idea. I saw that idea for Kafka once, to basically define a singular interface for the storage engine. That's cool.
And that interface exists already, because this is exactly what Tansu does internally. And I've thought about that quite a lot, because I think it would be quite interesting if the SQLite storage engine was a separate project to Tansu. Probably doesn't make a lot of sense right now, but it's ultimately something that could happen. And then the other thing that's cool about Rust is around the semantic versioning of crates, so you can ensure API compatibility. And people can grow with you as the API grows.
What do you find interesting with that necessarily, of the SQLite?
So I'm talking about specifically there, so the storage trait that is in Tansu right now,
The interface.
that is a crate that is semantically versioned, and there are rules within Rust as to how you can then change what you can change with that semantic version, what changes you can make, and it's very restrictive in terms of what you can do. But it also means that you have strong API compatibility with anybody who's using that trait. So it could be a third party that's producing something that uses the storage trait and is basically assured that it will still continue to work with the platform.
And this trait is literally just a Rust interface, right?
Yes, the closest thing to Java would be an interface. Yes, it's not an interface, but it's very similar to that as a concept.
So similarly, you're saying if I wanted to, let's say you didn't support Postgres, I would write some sort of Rust library or crate, as it's called,
Yes.
which implements your trait or interface.
Yes.
And uses Postgres in the backend. Because we have the specific versioning, you can. This is sort of your way almost of versioning the message log format in Kafka. Is that true?
Messaging versioning the interface is so at the moment.
Oh yeah, sorry.
All storage engines are in the Tansu storage crate, which actually, because there are now half a dozen storage engines, it would be quicker if they were individual crates, because you can get faster compilation in Rust if they're separated out into smaller crates. So there could be a Tansu storage PG, Tansu storage SQLite, Tansu storage S3, and they all use the same Tansu storage API underneath.
So then we get into the actual storage format, and this would lead me to ask you, are you coupled, or is the storage engine coupled to the underlying record format?
The API takes, well, the easiest thing to do would be to show you the API, wouldn't it?
Mm-hmm.
Then I'm not lying to you and trying to remember things that I've already shown, I can't remember.
Because from what I remember, you store let's say in Postgres, you store the record payload as just plain bytes. Even though you know the schema, you just store the bytes, that's correct?
Yes, and there is quite a good reason for that as well. So let's go here. So can you see that okay?
Yeah.
Is it showing me and the screen, or is it just you?
I see both, but yeah, I see the screen.
So let's look in. So the storage crate is cunningly called Tansu Storage, and in the lib is where. So this is also. I would like to show you the docs.rs as well at some point. I think my tool is getting a bit wide. I'm not quite sure why it's complaining so much about prop macro at the moment. But essentially, this is the storage trait that's defined. It's annoying that it's...
Yeah. So whatever, we have this interface.
Yes, and so you were talking about the produce. So the interface is the transaction ID, so you need to know if you're in a transaction. Topition is a topic partition. And then you get past a deflated batch. So at that point, it hasn't been decompressed. So the storage engine is responsible for inflating the batch and doing any schema resolution if it wants to. You could have a storage engine that doesn't do any schema validation if you wanted to. So it's very open from that point of view. You'll pass the deflated batch. So if you deflated means it's obviously compressed. So you could store the batch in Postgres as a thing.
Got it. You can store it compressed, meaning.
Yes. And the only thing you have to return is the beginning offset that you used when you wrote that batch.
Right.
Because that's what you need to return back to the response. So I think it's certainly this one is pretty flexible in terms of what you could do. So if you wanted to write a file system storage engine that stored things as segments, you could take deflated batches, compressed batches, and store them in the file system as segments in the same way that Kafka would do it regularly. Fetch is pretty similar. Top partition, the offset, minimum, maximum, isolation, and then you return back a vec, which is a list of deflated batches.
So, and why is the reason that you store it just as opaque bytes in Postgres, for example?
Rather than a table?
Yeah, let's say.
So, see, when you asked me this question a couple of weeks ago, I had a really great answer that was just on the tip of my tongue, and I'm not remembering that really great answer. The problem is for a start, you've got to create the table. So that isn't something normally that applications do. It's kind of...
I think I can remind you of your answer. I think you said something about the partitioned tables in Postgres and that feature and how the big... So for people who don't know, I ran Tansu once and it created like this big records table in Postgres that holds records for actually every topic partition. And then I messaged Peter and I asked him, hey, does this scale? Like, how come we have one table for absolutely every topic partition? Shouldn't you shard it? And then he told me that it's sharded under the hood actually through a Postgres feature.
Yes. So I use a Postgres feature. Record's such not a good thing to create. Let's try table record. So don't think this will give me, I'm going to have to search for...
Yeah, you don't need to pull it up necessarily.
Actually partition would be a good thing to... Yeah, so there you go. So the headers, for example, are all partitioned by the top partition. And this is that's the view, but...
Could you also zoom in a little bit? So this says create table, yada yada, and then partition by...
How does that work?
The topic partition, yeah, that's perfect.
So this is the table that is used for storing all records, and I mean Kafka records rather than records. So you're absolutely right. I store the key, which is a byte array, and a value, which is a byte array. So I don't know. They're basically stored in Postgres. So if you're not using schemas, it's fine. You've got some data. You've got the JSON if you want the JSON. If you are using schemas, then it is just the protobuf data rather than the decoded data.
All right. So you can't necessarily write a Postgres select this record from here and join on this field, etc.
No.
As of now, no.
No.
And, but then a similar question is, how does this scale for Postgres in the long term? Like, do you support retention? So allegedly you delete these records after?
I delete. So on SQL storage engines, yes, both SQLite and Postgres, it will delete on delete. It will also compact as well.
Do you foresee any sort of scalability issues when you collect a lot of records, or?
I don't think so, because the whole idea of this partition by top partition is kind of how Postgres deals with this as an issue, is that you can partition these tables, and what effectively it's doing is it is creating separate indexes for each top partition. So if you want to get, I frequently need to fetch a record by top partition and offset ID. That is the partition. So that is in its own index per topic partition.
Yeah.
So it should be really quick in terms of how it indexes.
It's technically its own table, right?
Underneath how it's done in Postgres, that could be. And I'm not in. It's essentially a virtual table, I guess.
Yeah, that's my understanding.
But the thing I was mostly interested in was around how it does the indexing, because that to me is one of the great benefits. The table can grow as long as you like, but if the index is covering lots of other things, then it's not great.
Right. Yeah, okay. And then also from the SQLite side of the story, again, SQL, we talked once about this idea of just embedding the storage within the app itself, and also this possibility of since SQLite is embedded, you can, in theory, load a fresh, or well, you can load an old Tansu cluster or Tansu broker with a brand new machine and sort of save state that way. I think that might be useful for testing purposes. You can create pre-created Kafka clusters with your particular test data, particular offsets, particular state, really, that you just want.
Yes. And again, it's the whole thing, because everything is stored in SQLite. So you can back to sort of previous experiences of building an integration environment or a test environment, and half the battle was does this have exactly the same data that it had a week ago? Why are the test results 10% different to what they were?
Exactly. It is exactly this in this example you gave me, where you built the trading system with the HTTP response and everything. How did you test that system integration wise back in the day?
So
did you? Was that before the extreme programming day?
No, it was well after. So the cool thing there was, because everything was in the same place, we could create bit like I was. Let me show you the bench that I was kind of talking about. So we've talked a little bit about this is the test, and I am trying to get to exactly your question. So here's the bench test. So I've got a codec request, which is what I'm expecting of these bytes, and these are bytes that I've captured.
This is your saved packets, yeah.
Yeah, exactly. So
Peter's collection of Kafka packets.
Exactly, and it's a weird collection of all. So this is version 3, version 1. I have different instances of them because I ask different things, and there are lots. There's create topics and response. So to answer your question of how do we go about testing that? Well, the really easy answer to that is very similar to this. We would have collections of data that we knew as this is our state, and here are these transactions coming in. And rather than going through Kafka, because that's hard and slow, we would just feed them straight into the fetcher, what we call a fetcher. So we'd pass in that data. So we could very easily say, this crash has just happened. How can we prevent that from happening? Here's the data that we started with, and just reproduce it each time.
So you sort of had your Kafka stub, basically.
Yes. Yeah.
But now with the SQLite Tansu, if you had Tansu back then, could you just have used, let's say, a preloaded SQLite database?
Everything would be simpler now with Tansu, yes.
Right, so your CI/CD would just spin up a Tansu broker with the local database that's version controlled somewhere.
Absolutely, yeah. Yeah, and you could also, so you could either just write data into Tansu using the Kafka API, or you could create the records using SQL and build your data that way.
Yeah, I love that, because it also, in theory, allows you to, could you shadow traffic? I'm not sure, but you can make a copy of a production Kafka cluster as well by just reconsuming everything from there into a single SQLite.
Yes, so I've got an example of that. I've got an example of using MirrorMaker to do exactly that. So you can use MirrorMaker to basically take some topics from a existing cluster and put them into a different Tansu cluster. I'm saying cluster, single broker.
Yeah.
But using different storage.
I love that. I think that's underexplored and undermarketed, actually, because I don't know if people understand you can actually do this today.
Part of it was, I wasn't sure if it was just a problem that was unique to me, or it is just something that I haven't explained particularly well, because I think it's a really, having been an engineer using Kafka, a reasonable amount, it's one of those things that you kind of go, wouldn't it be cool if you could do this? So I'll just share.
It cannot be unique to you. It must be a way more common problem.
I'd like to think I'm so completely unique that, yeah, I don't think it is at all. I think it's something that people have. So, for example, part of being Kafka compatible is we can use the existing tools. So I've got an example here on docs.tansu of a compose, and I've got two brokers here, A and B. They're both using SQLite, but and I'm using MirrorMaker, which is part of Apache Kafka, to do that mirroring. And it's as simple as that to basically set it up. And you could have, here you've got SQLite, here you've got SQLite, but one of those could be S3 or one of them could be
Crazy.
Postgres. And it would just copy between the two. And you've probably seen hundreds of these. There's nothing special about the mirror making properties at all. It's just normal Kafka.
No, it's crazy how simple that compose file is.
But we also, you kind of touched on a little bit on something that Tansu also does as well. And one of the things is around this idea of test data. So there's a generator subcommand as well, which is part of the Tansu single binary. And what you can do is you can, this is specific to protocol buffers, because protocol buffers does this in a very nice way. You can basically say, here's my schema for my topic. And what I want to be able to do is for this email address, I want you to generate an email address for me. And Tansu does this out of the box. You can basically tell it, here, create an email address, create a full name, and use first name and last name to do this. The rhai scripting engine that I was talking about a little bit earlier, about using that in the proxy, that's the broker already uses rhai to do this. So these functions are actually rhai scripts, so they can be quite complex. So for example, here it's generating the industry, it's creating between 1 and 3 industries for this customer in their profile because it's a repeated string. And basically you can just run it through the generator. And so you run the generator like this. You can say how many producers, how many batches, how long you want to run it for, how many messages per second. And you can then use tansu-cat consume, which will then consume the protobuf encoded messages, and you get test data directly from Tansu, which is an engineer to me a really interesting thing to be able to do. If you've got these schemas, the idea around this is the schema is the single document. It contains the schema of the conforming to the messages, but it also contains the generator, so you can generate test data for addresses.
It surprises me how many features Tansu has and how end-to-end it is in terms of how young of a project it is too.
It's all the itches that I've scratched for 10 plus years of Kafka angst.
But I think that's very valuable, and that's why I love your project is because you're just a single person who knows what he wants and he just does it. I find that in a lot of bigger companies or commercially oriented companies, there's a big disconnect between what customers want and what product accepts, and also what the people in the middle kind of want, which is the field team, if you will, or the people dealing with the customers. I've heard a lot of complaints from a lot of these companies where product has one vision that they're stubborn on, the field is seeing something else that could be very desired, and basically a lot of the things that get dropped are exactly these little quality of life improvements that, similar to the flame graph, maybe one is a small enough feature, but when you stack everything together can sort of make or break whether you want to use something or not.
Absolutely, and I certainly don't know if I'm right or wrong, but I certainly know that these are issues that I've experienced, and I'm hoping that there are a sufficient number of engineers that are also.
Look, I can tell you, I find it very cool. I find it very useful, and it seems like everybody today. I've written about the commercial side of the Kafka business, but every company. This is the incentive of our world today. Is every company is VC funded, meaning they're chasing that 300% growth, that hockey stick chart, which by definition means that you're not gonna get it when you just create a nicer CLI or create a data generator. No, you're gonna get it by completely changing the paradigm, maybe supporting AI agents or whatever else the latest hype is. And it's kind of like you shoot for the moon or you fail, and that leaves this neglected part in the middle, which is the quality of life and making existing things just that much nicer and more pleasant to use. I think it's completely ignored by every vendor today.
Well, that's very nice of you to say. And I'm an engineer. I'm very happy being an engineer. I really enjoy being an engineer. I enjoy the process. And to me, I'm just fixing engineering itches. And if I can make a really fast, lightweight, small broker that kind of looks like Kafka, smells like Kafka, but isn't Kafka, it can also do modern things that I'd like it to do, like schema validation, generate code for me, generate data for me. They're all just things that I think should be useful to people.
But I also think you're underselling it when you say it's not Kafka, because from what you've shown me, it literally is Kafka. Having having schema validations a little different, not supporting the full API, of course, but from what I understand and what it looks like, it more or less is Kafka, what you're building.
Yes, I did. So the nice thing, one of the nice things about protocol is when the client connects to the broker, one of the first things it should do is send an API versions request to the broker. And Tansu tells you exactly what it supports and what it doesn't support. So the security side of things and the ACL I don't currently support, just will support, but I can add those in.
Yeah, that's fair. I mean, it's an enterprise.
So it does. It supports fetches. You can create topics in the same way you'd expect. What I mean in terms of it's not Kafka is it's not writing segments.
Okay.
And it's not using Raft, and it's not using those things.
Yeah, it's again a very engineers focused way of looking at it. But if you ask a product guy, is this Kafka? They'll say yes, this is Kafka.
It's Kafka.
No, it's not Kafka. No, I'm flipping now. I'm going back to my roots. It's not Kafka. But yeah, the fact that it's not Kafka and that you're outsourcing replication away to the backend, it unlocks so much. I feel like I'm repeating myself, but it simplifies Tansu so much. Like it makes your scalability story easier. It makes your durability story much easier. You don't have to explain what the durability guarantees of Tansu are, nor do you have to. It's really hard to implement replication. I'll tell you that. I've seen the edge cases we've hit in Kafka, especially when like one replica falls back and then you have to catch up, or then you get a new leader. Like it's exactly in these edge cases where you change leadership, you change the log latest safe offset that you can get. And then if you do that like 10 times within a second, that's when you get the nasty bugs. So yeah, I think that was a secret of WarpStream and these other sort of diskless Kafkas, how they were able to ship so fast is what they basically didn't have to do 70% of the work in a way.
Yes.
Not to diminish the 30% of the rest of the work.
But I do massively agree with you. It couldn't be so this is a single person project because of the decisions that I've made in part to make it a single person project. So it's not using Raft, it's not using replication and all the issues around that, because they are hard problems. But there are other things that you can use that can kind of at least mitigate that problem to make it more manageable, like using Postgres and those kind of things.
Yeah, so consensus and replication, the basically hardest parts of any distributed system, are outsourced to it could be a distributed system like S3, it could be just SQLite, which is not a distributed system, but doesn't matter. But that again unlocks your... sorry, were you going to say something?
No, I'm good.
That again unlocks your CI approach and single binary approach. You can just put this in any CI. You can put it in any test case. You can literally embed it in your tests, if I understand correctly.
Yeah. Yes. Thanks to a recent contributor, it even works with cargo install. I'm not sure who did that, but somebody did that recently. So you can literally just do cargo install. You've got the Rust toolkit installed on your machine, and cargo install will just work, which is kind of nice. So there's no binary to download. You can just install it yourself directly from crates.io. And there's a Docker image, and people think I'm crazy around these things, but it's a from scratch image. So there's no operating system with Tansu in the Docker image. So the Docker image is 50 megabytes. When you do a Docker pull on Tansu, it's a 50 meg pull because it's just pulling the binary. There's no Debian or anything like that that's there. It's a single binary, statically linked, it's compiled for both ARM and x64 in the same Docker image, so it's super simple to use.
That's so awesome. I got some deja vu when you said the cargo install. I think I contributed parts of that PR.
Contribute that, yes.
That was me.
I was expecting you to go, yes, that was me.
No, I forgot about it. But I didn't do anything. I just debugged it for a day. I think it was mostly working.
But that's the great thing. And the hair's going on the back of my head. That's the great thing about open source, that you get contributions, which is very cool.
And I wanted to ask you that too. Are you looking for contributors?
Yes.
Are you inviting contributors to the project?
Please contribute.
How would you invite somebody? Like, is there any big feature you want people to help with? Big feature you want people to help with, or are there small things, or is it just anything?
Yeah.
I get, just to give you some context, I get frequently asked, how do I contribute to Apache Kafka? I find that people have a hard time starting, and I don't blame them. I had that too. It's hard when you see a big project to even know what it is, how it works, and at the very least, where to start.
So yes, I would very much appreciate contributions. Contributions of any form would be extremely good. You've probably noticed that documentation is not something that I'm particularly great at, but I'm very happy to help guide people in spaces. The Slate DB was a kind of good example of I started something, lost interest, you could argue, and then somebody else offered to pick it up. So there was kind of the framework there, and I'm more than happy to do that with other areas. Somebody else had suggested something recently that I've now completely forgotten. But any area in that space, and I guess also the flip of this, I'm very aware that this is a single person project and there's risk around that. And I'm very interested in getting closer to Apache, Kafka, and becoming more of a thing rather than a different thing, just so that perhaps things like the client can be more widely used. If that makes any sense at all, because I think Rust and the idea of having a client Rust is way bigger than Tansu. Mm-hmm. I think it would be an interesting thing as an Apache or a CNCF or similar style project. So I'm quite happy to lose control of Tansu if it can become part of that wider thing, which I think would be also an interesting space, because I think it would be useful for the whole collective of the Kafka world. That doesn't make sense.
No, I got that. I just remember that Datadog actually built their own Kafka client in Rust too, called lib streaming.
I didn't know that. I'm going to have to go and look at that.
It's not public though. I think it's only in a blog post. But maybe if somebody from Datadog is looking at it, maybe they should take a look.
I think the whole story of being able to operate beyond Rust with a Rust library that is a Kafka client, I think could be interesting.
No, that's exactly what they actually. Let me share my screen really quick, just so the audience is on the same page too. Mm-hmm. Okay, yeah. So they had this blog post here where they talked about achieving relentless Kafka reliability at scale, and they were explaining how they used Kafka. It's very interesting, their whole platform. They have a lot of Kafka clusters, and they proxy clients in between clusters and host like a lot of stuff. And they sort them with specific cells, so they have certain blockers that are for like different quality of service lanes, I think it's called. Like some topics can be slower, some can be a dead letter queue, etc. But in any case, I think a little bit down here they said that they had to build their own client, which is here libstream.
Oh, okay, cool.
And they actually do have bindings for Java, Go, Python, and even other languages.
Cool.
But yeah, they tried to use RD Kafka, which is a C thing, but they found challenges like the STD bombs and other bottlenecks.
Oh,
so
cool.
I'm not sure. Yeah. It's proprietary from what I understand. Right. I'm not sure how catered it is to their platform, but I think they might be interested in using an open source client. I mean, look, they first tried to use RD Kafka. I doubt they want to be in the business of supporting a Kafka client from scratch. But yeah, maybe we should see if we know anybody from Datadog.
That would be very cool as well to think about. I do think that's one of the interesting spaces around Rust, the fact that there is this whole ecosystem around Rust, but it also fits very nicely into anybody that wants to use that can use something that has essentially a C API. So integration with Python and such like. It's interesting that they've got Java using it. That's very much an interesting one. But yeah,
it is. Yeah, maybe they implement some custom things there. But okay, awesome. Yeah, we talked about a lot today. Thank you so much for.
Thank you very much.
Thank you very much for taking the time to talk to me for so long. I had a lot of fun discussing everything, and it was a perfect conversation in my mind in terms of both low-level engineering talk and then going back to like high-level applications and usability and potential ideas, and then back to some Rust code. I love that. I think our audience will too. So Peter, again, thank you so much for coming on. Do you have any call to action to anybody who watched the full, let's say, I think it's 3 hours now, 3 hours and maybe something of an interview? Like, where can they follow you? Are you active online on social media? Do you blog, or do you just produce code and commits?
That's all. That's all that matters, isn't it?
Yeah.
I'm on Blue Sky, but I'm very irregularly placed on there. The easiest way is just to reach out through GitHub. And please, I'd be very interested in any feedback from people. And probably, if you've tried Tansu and it didn't work, I'd love to know why. Would be my main thing. Because what I'd really like to be able to do is get it to be as API compatible as possible.
Yeah, and for that we need testers. So just spin it up, see where it breaks. That's how I contributed my cargo install. Actually, I tried to spin it up, and I'm allergic to Docker, so I just tried to run cargo install, and it broke. And I had some time and I fixed it.
And it works now, and people are using it. So yes, very cool. Thank you very much for your contribution. It's much appreciated.
Thank you for your contribution to the Kafka space, because this is innovation and it's a Apache license, which is also extremely important. I'm excited to see where this goes, and I'm bullish. I think it will go a long way. I think we'll come back a few years, maybe we'll interview again, and we'll see what has happened since. But I think it'll be greater than what it is today.
Not a few years though, because there'll be another dozen storage engines by then, and it'll just.
Yeah, the 44th storage engine. We'll see what that is.
Cool.
But yeah, thank you so much, Peter.
Cheers. Have a good one.